Yes.
Yes.
Yeah, yeah. Voice is
Yes,
Good
sir. Good
evening,
evening,
sir.
sir.
Yes, sir.
Good evening.
Good
All
evening.
of you.
Good evening, sir.
Okay, so this is revision session. So first we will discuss the all topics of from week 1 to up to week 4, and after that we will go with your doubts. Okay.
Sure.
Yeah.
Okay, sir.
Yeah, it's visible. Okay, fine. Yeah, okay. So we will start from the week 1 first. Okay. So in week 1, I will start with the statistics. Okay. Yeah, there is two branches of statistics. First one is descriptive statistics, and second one is inferential statistics.
Yes,
Right?
sir.
And what is descriptive? Descriptive is nothing but descriptive is consider when we have to summarize the data, when we have to describe the data, and describing the data means to you say some calculating the mean, median of data. You are display the data. I mean by any chart, etc. Suppose suppose there is a batch of 40 students in a class, okay, and I'm taking a suppose I'm taking the marks of 15 students, okay, and I calculated the average marks of these 15 students. I
Sorry
got
to
suppose
interrupt.
I got
Hello.
suppose
So sorry to interrupt.
yeah,
Your voice is a bit
yeah.
lagging. Your voice is a bit lagging. So can you
Yeah.
please just check your bandwidth and all? It's a bit lagging for us. Maybe it's for me only, or if anyone else is there.
I think I'm finding it okay.
Yeah,
it's fine. You can
properly.
okay.
Just fine,
Okay,
sir.
okay, now, yeah. So please let me know when why there is problem of voice, etc. Okay,
Yes, sir. It's
suppose
fine.
there
It's
is
fine.
a batch of 40 students. Okay, fine. And I took the sample of 15 students and calculated the average marks. I got the 65 marks. Then this.
Hello.
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 Hello, sir.
Hello.
I think the sir
Yeah,
got
yeah.
disconnected.
Hello.
Got
Yes.
disconnected.
Yeah.
Disconnected, I guess. Yeah.
Yeah, hello.
We can hear you, sir, but the screen is not visible.
Yes,
Sir,
sir.
the
It's
screen is
visible.
visible now.
Yeah. Now visible. Yeah.
Now visible?
Yeah.
Yes,
It's
sir.
visible.
Okay, fine. See, then here I have described the data. Okay. So this type of statistic called the descriptive statistic. Suppose I am making the conclusion on the behalf of this average marks. Suppose I am saying that the average marks of total students is 65. Then here I am making the inference on the behalf of sample. Then this type of study is called the inferential statistics. Got it?
Yeah.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
I hope till this point you don't have any doubt. Okay. And so what is population and sample? You know very well.
Yes, sir.
Okay. Population is
Yes,
something,
sir.
suppose the total collection of all the elements in which we are interested. Okay, suppose here I am interested to know the marks of the whole class. So I collected the elements, means I collected the whole, I consider the whole number of students. So this is the population, and sample is something which is a subset of the population. Okay, suppose this is the your population, and your sample will be the subset of the this whole things. Okay.
Yes, sir.
Okay, sir.
Okay. So next topic is data. See, data is something. What are data? Anyone can tell me? What do you understand by meaning of data?
This is a collection of information.
Yes, sir. Collection of information.
Yeah. Actually, you can say data are facts and figures which are collected for analysis and summarization type of thing. Okay, and there is two types of data. First one is structured data, and second is unstructured data. Okay?
Unstructured data.
Also, please let me know when by mistake I skip any topic. That will not happen from my side, but okay. So what is structure? Let me start with unstructured. Unstructured data is something which is not organized in a predefined manner. Okay, you can say not organized in a predefined manner. And structured data is your organized in predefined manner. From the
So
structured
please
data,
check your connection. Your voice is lagging too much.
Yeah, once again, your voice is
Yes,
lagging. Yeah.
sir. Yes, sir.
It's lagging a little
now is
bit.
it okay?
Yeah, now it's okay. Means somehow it's okay, but yes, when it will get started once again, then we'll inform you. Yeah.
So in between your voice is lagging actually.
Okay, I
Yeah,
think
yeah.
there is some network problem.
Yeah,
Now it's
go ahead,
okay,
sir.
right?
Go ahead, sir. If
Okay,
anything else
okay.
will happen, then we'll inform you. Yeah.
Okay, fine. Yeah, structured data is something which is you can say in a predefined format, and from structured data you can easily search the information. I mean, suppose I'm saying, suppose there is name of students, and you can say course of students, and you can say marks of students. Okay, so there is A, B, C, D, and course, suppose I'm saying math,
Sir, your voice
and
is
B is
lagging.
from stat 1.
Sir, your voice is not clear. Voice is very lacking.
One second.
Sir, please restart your device, sir, please.
Can I check your bandwidth? Maybe issue in bandwidth, I guess.
No, sir, it's still lagging.
Sir, the reason may be you are live streaming. So when you do live stream, it takes a lot of bandwidth.
Yeah, so that's why I'm saying. Maybe live, and another one is the screen sharing is going on, right? So that's why the
That's
issue
true.
is happening. Yeah.
Now
No,
sir,
it's
it's lagging even more.
lagging more.
one second, let me
Is it
let me
possible
read.
to pause the live stream?
One second.
Rejoin
It's
again,
not
sir. It's
possible.
gonna
Let
fix it.
me. Yeah. Let me read. Hello. Hello.
Yes, sir.
Yes.
Yeah, yeah. Now am I audible?
Yeah,
Yes.
it's good.
Yes, sir. Yes, sir. Yes.
Okay, okay, fine, fine, fine.
Maybe the screen sharing is an issue with taking a high much of bandwidth and live as well.
Oh yeah, I think let me. Okay, so I think currently I'm unable to sharing my screen. Yeah, so let's discuss it. Yeah, so structured data is something you can say it's in a tabular form. Okay, and unstructured data is not in tabular form and is not in any predefined manner. And you can say structured data is clearly defined, and you can search any information in an easy way. Okay. Oh no. One second, one second.
Yes, sir.
Yeah, is my screen visible? Yeah. Okay. Fine. Fine.
Not
Yes,
yet.
So let's. Yeah. So suppose there is.
Sorry, sir, I'm not able to see your screen.
So your screen is not visible.
Yes.
Yeah, it's
Your
not
screen is
visible.
not visible.
Not visible, sir.
Hello. Yeah. And suppose audible.
Yes.
Yes, sir.
Yeah, it's breaking. So your voice is breaking again.
So
No, it's clear, sir, now.
Okay. So this is data tabular. Okay. So you can say this is a structured data, right?
Not able to view the screen and your voice.
Yes, sir, it's coming up. Yeah, it's coming up, but not. Yeah, now it's visible.
Now it's visible,
Yes,
sir. Now
sir.
it's
It's
visible.
visible.
Now it's visible, sir.
Oh, fine, fine. So this is the data which is in a tabular form and it's in a predefined. So it is a structured data. Okay, and unstructured data something. Suppose I'm writing is a student. Okay, which is which opted math one course. So
Sorry, sir. Again and again, we are interrupting in your classes, but seriously, your means voice is very lagging. Sir.
And now your screen is gone, sir.
Yeah, it's gone.
Sharing
It's
is
not
on.
visible as well.
15 minutes is also gone.
Sir is also gone.
Sir left.
I think sir is reconnecting.
Quiz is also
No,
gone.
sir gets disconnected. Now he will reconnect.
Sir is trying to.
I think there is some problem in his network connection.
Internet issue, maybe.
Yeah. Maybe the connection is not good as well.
Yes, yes, yes.
Should use Airtel internet.
There are other instructor also. They have good connection from network connection.
Guys, when do we have statistics maths mock test? Sorry.
It's
already
tomorrow.
released. I don't know.
Tomorrow it got scheduled.
It's
I
tomorrow.
don't know when
Tomorrow.
was
It is
released, but
scheduled for tomorrow.
Yeah.
Tomorrow.
there is no such schedule. I
Hello?
can
We
see
had a
the-
doubt session in the
Hello?
notes, I think.
Please,
Yeah, we'll be having.
please check the mail. We
Sir
have
is
you
back,
get
sir
the
is back.
information about the mock test.
You can check
Yeah,
your
hello?
calendar also. If
Yes,
yes,
sir.
sir, you are audible.
Hello. Yeah. Okay. Fine. Fine. So sorry for I did actually I did. Yeah. So suppose I'm writing like not any defined manner. Suppose I have written like A is a student which opted math one course and
I'm not able to see.
his marks is 72.
Not able to.
And again, I'm writing the just.
Not able to see.
Your screen is not visible.
Sir, can you share your screen, please?
So the screen is not available.
Sir is also disconnected.
I think there is some
Tomorrow
technical
is
issue.
CT mock test, right?
Guys,
Or
on
statistics.
screen it is showing
This CT and stat. Guys, you are able to view the average score of statics on your dashboard.
Yes,
No.
it is visible.
See, for CT, it is there. For
Except
computational
statistics,
things.
Statistics, I'm asking for
No,
statistics.
Not visible.
they are updating. They are updating.
I'm also not.
Okay.
Before 1 hour, I was able to see English, and now I am able to 3 of the subject. Average.
I am only able to view only 3 subjects except
Me,
statistics.
me too.
Yeah. Okay. Thank you.
ना करा वो छुए में ना लाऊं
Can you guys mute yourself?
Yeah, hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah,
Yes, sir, yes.
There was a lot of network problems on my side. Yeah, is my screen visible?
Sir, voice
is breaking out.
and screen is not visible.
Okay, 1 second.
Yes. Now your
Yes,
screen
sir,
is
visible.
visible.
Hello.
Yes, sir. Visible.
Yes, sir.
Your screen is visible.
Hello.
Yes, sir. Visible.
Oh,
Yes, sir, visible.
Visible, sir.
oh, fine. Where I think I was on unstructured data.
Yeah.
Okay,
Structured
so-
and unstructured data.
So unstructured data is something when data is not in a defined manner, in a standardized format, you can say. Okay, so I think doubt is clear regarding structured data, right?
Your voice is breaking down in between.
Sir, your voice is going up and down and breaking very.
Okay, sir. Who is eating?
Whoever is eating, please mute yourself.
Please mute. Who is eating?
I think it's Pawan Kumar.
No, man.
Eating kurkure.
No, I'm not eating. Yes.
Sir, it's trying to reconnect and once again, yeah, it's internet issues are there.
Now it's disconnected again.
He's trying so hard.
I mean,
Appreciate it.
Okay, so we really try hard, nothing to laugh.
Hello.
Okay.
Sorry.
Thanks.
Yeah. I will continue this. I think this connection is breaking from now.
Voice is clear, Mr. Ishan.
Okay, yeah, thanks. Okay, so yeah. Okay, so we are at week 1. Can someone tell me which topics have been recovered by now?
We have structured and unstructured data. We already
Structured and unstructured data.
Okay, so you have understood structure.
Sir, I have a doubt in inferential and descriptive. Can I ask?
Okay, yeah, okay. Let me just start from the beginning. I think that would be better.
Sir, start from the beginning. Huh?
Yeah, I'm doing that. Just give me a minute. I have to.
Sir, hello.
Yeah.
So when will you be taking doubts from the mock test, if you will be?
Mock is only one mock is released today, right?
Yes, sir.
Tomorrow we will release another.
Mock is there? I'm sorry, I was not aware.
Yeah, one mock is released today, one we will release tomorrow.
Okay, it's already released, is it? Oh.
Yeah, and then we will have a mock session on Thursday where we'll discuss both the mock tests.
Sir, we are not getting
Okay, sir. Thank you.
Sir, what will be the deadline of mock test?
If you haven't cleared qualifier earlier, then it will be a timed mock tomorrow. Okay, just like you give the quiz exams, it will be something like that. Okay.
Okay, sir.
Okay,
And if you have cleared the qualifier already, it would be just normal assignment. You can do it anytime.
Sir, mock is not showing in my dashboard.
Yeah, guys.
About that, sir, I think there's have been some error. It is released before time. Mock test is showing before time, as well as the solution PDF.
Yes.
Also, timer is not.
It has been released before
guys,
time.
one request to all of you. This is very important time, and Sag is giving time for us to clear the doubts. So this general question we can ask at the latter, at the end of the session, please. So let's start cover the important topics from week 1 to week 4. So let us.
Yes, sir. Please start covering the topics, sir. Please.
Yeah, kindly bear this.
Yeah, we'll choose that. Okay, so starting from, I think I will start from descriptive and inferentials, or you can say that. Okay, we will start from descriptive and inferential statistics. Okay. Okay, so I think by now you all know what is statistics, right? Statistics is just a field of, where we learn from data, we collect data, we do some mathematical or statistical operation on it, and then draw some inferences from it, and something like that. So in general, we define statistics in 2 fields. Okay, one is descriptive, another one is inferential. So yeah, descriptive statistics we can do on both sample and population. And for inferential, we use sample to draw some conclusions about the population. Okay. So before going into that, we must know what is sample and what is population, right? So let's say there are several tasks that you might want to do. Okay, let's say the board exam for class 10th, okay, has occurred, let's say, few months back. So, or you can say the past year record you can consider. So I'm interested to know the mathematics score. the mathematics scores of all the students, right? So my major interest, or you can say I'm interested only in the CBSE board over here. Okay. So here, if you see, my major focus is only on the class 10 student who are in CBSE board and who have mathematics as one of the subject, right? So from my study is to know the mathematics score of class 10 CBSE boards. So my population will only be all those students who appeared in the class 10 CBSE board examination and has mathematics as one of the subjects and have given the exam. Only then I will be able to collect the scores of mathematics, right? So that's my population. Population is, what we are interested in basically. So if you look at this, there will be, let's say some 2 crore students appeared in this exam and have mathematics as subject. So I won't be able to gather data for all 2 crore students. Okay. So what we do is, let's say this is my complete population of 2 crore students. I just take a small portion of this population, just a small, whatever possible. Like I just, for instance, I take, a few lakhs student data, whatever, from wherever I can get, I get it. So see, this small portion of population over here, this is what we call as sample. So why we take sample? It is because it is impossible kind of in this situation to get all the data of 2 crore students. So we take a subset of those 2 crore students and then we perform operations on them, and then we conclude like, okay, yeah, this could be the average marks of student, or this could be. Then we draw inferences about the whole population on the basis of this small sample or subset of my population. Okay. So any doubt in sample or population?
Sir, I have a doubt on inferential statistics.
Yeah, we'll cover that.
Hello?
Okay. Yeah.
Hello?
Going to that. Hello?
Yeah, I have a doubt on inferential statistics.
Yeah, we are going in inferential for now. We have just covered sample and population.
Okay.
So suppose this is our data. Okay. This is my sample data, which I have collected of these few lakh students, of these 2 crore students. Let's say student roll number or something and their marks in maths. I have this data. Anything I can, I can summarize this data in any way. Like of these few lakh students, I can say that their average mark is 76, or maximum marks is 100, minimum is, let's say, somewhat 21. So whatever I can summarize from this data, it all comes under descriptive data. Okay. If I have sample data, I will be describing my sample data. So I can do descriptive statistics on sample. If I have my in case, it is possible that I can go and collect all these 2 crore students data, and I have that data. So if I am summarizing this population data, then it will be again descriptive statistics on population. Okay. But in most of real life cases, you will see that it is not possible to go and get complete data. So in real life, we have only the sample data. Okay, we generally draw or summarize this data, and on the basis of it, we use some statistical technique to conclude something about my population data. Like here, we say that average of my sample data is 76. So I can conclude that, okay, for population, for all these 2 crore students, average will be somewhat around 76. Using some statistical techniques, we can do that. Okay. So for inferential, we use sample and conclude about population. Whereas in descriptive, we describe only the data we have. Any doubt in this?
Yes, sir. Whenever there is no concept of sample, there cannot be inferential.
Whenever there is
no concept of sample, we are not taking any sample. Whatever data is available, we are doing everything with it. Then whenever there is no concept of sample, there cannot be inferential.
Yeah, only inferential is we use sample to conclude something about my population.
Sir, I have a doubt on
something can be both descriptive
statistics.
Yeah, continue.
Sir, is there any chance that something can be both descriptive and inferential?
In general, we do both, right? Okay. If you see, to get this inferential statistics, I first did my descriptive one, right?
Yes, sir.
But if we are doing somewhat this complete procedure, we name it as inferential.
Sir, in this particular example, we are inferring the average of the population from a sample of data, right? So that is like in terms of size we are inferring. Can we do it in terms of time as well? Like suppose there are 100 students who are appearing in quarterly exams, right? So we have their marks for 3 quarters. We have their averages for 3 quarters. If we infer the data for those 100 students only for the 4th quarter, would it be inferential statistics?
Oh no, that's something comes under time series data. We have a different field of statistics that works on that. Okay.
So that won't be inferential statistics?
No, that won't be.
So it won't be descriptive. It won't be descriptive. It won't be inferential. It would be a third kind.
Yeah, we have some different field of statistics to handle such, but inferential we have some set. It is not possible for me to get this all data, right? So I just take a subset of it, and from this I predict about my complete population.
So it is compulsory for the data to be cross-sectional to be inferential, right?
Yeah, you can say in some sense. It is okay. Yeah, you can assume like that, but not to be exact. Yeah.
Sir, whenever there is inferential, we are drawing some summarization out of the sample and then drawing conclusions for the whole population, and we call that inferential. So whenever there is inferential, there is always descriptive for the sample.
Yeah, we always see without summarizing this data, I cannot conclude something about my population, right? So yeah,
Sir,
descriptive
but in
part is
one
somewhat
activity question, it is given some data is descriptive in the activity question 1.13. So here given that the study is inferential but not descriptive, but
yeah,
so
whenever this complete procedure happens, we name it as inferential. We don't call it both descriptive and inferential.
Okay, sir. So whenever such question come, we will never try to attempt, say that
yeah,
this is inferential.
You never say that both of them are occurring at the same time.
But actually, in real, whenever we are drawing, whenever there is inferential, a descriptive statistics also occurs for the sample.
Yeah, we first summarize the given data, right? And then we conclude something about it. So the question which you are referring is, we concluded that, okay, let me
so when we are saying descriptive or inferential, it is mostly for the population. We don't take the analysis of the sample into consideration.
The question you are referring to is in that question statements, right? This line is written. We concluded that roughly 80% students want to write the exam.
Yes, sir.
Okay, so my question is based on only this statement. For this statement, what field of statistics I am doing? So if I am concluding, that's inferential.
Yes, sir.
Okay. So yeah.
The other way of taking is like inferential is something like prediction. When we get something meaningful output, it becomes descriptive, right?
Yeah, if you are getting something only about this data, it's descriptive. If you are trying to conclude something, then it goes to inferential.
Yeah, because if inferential is something just like a prediction, we are getting some sample and we are assuming something like that. The moment we get some meaningful output from that specific data, it becomes descriptive.
Whenever you see words like predict, conclude, you can directly answer the inferential.
Yeah. Means any operation which has been done there.
Yeah, or you can also take a that for or let's say Virat Kohli's data has been taken for some previous innings, and some media reported that concluded that let's say we have taken the data of his 15 matches only. On the basis of that, we concluded that his overall average will be 50. So that's something I am concluding, right?
Yeah. Okay.
Sir, Actually, I have a, it is not directly linked, it's just for my personal query. So like you said that the population is 2 crore and from there we are taking the sample. So is there is there a definite number we have to take for the sample, or it is any number we take for with respect to the population?
Okay, so yeah, there is in statistics, very wide field. There is another field of statistics which we call sample survey. Okay, we have a lot of, you can say, 10 to 15 sampling techniques we use in different scenario to get this sample. It's not just like I am selecting something. We have various different sample techniques in different scenarios. Using that, we get our samples. So we are not going into that for now.
Okay.
Yeah, that's a different field of, you can say, a different subject in some sense.
No, actually, sir, what I was asking that, like, suppose the population is 2 crore, is there a fixed number of amount like 10,000 or 50,000 we have to take for the sample, or there is nothing like number or anything like that?
There is nothing like number. We have, as I mentioned, there are different techniques, right? So it depends on which technique I am using, which techniques.
Okay.
It's
Understood.
all depend on different techniques. Yeah.
Sir, I want to ask one question.
Yeah.
Sir, we will revise from week 1 to week 4, right?
Yeah. Okay, I think few
Sir,
people are
so in
raising
limited
hands.
time- Continue, sir.
Yeah, Himanshu Dikshit. Continue.
Sir, in limited time of 2 hours, is it possible to revise all of the?
No,
Although we are-
last term it goes for 3 hours, as I remember.
Although we are doing so much discussions in between.
Yeah, we have to do that, right? If only I have to, I can, keep on explaining concept and write it. It's just like you are watching the lecture, and even Usha ma'am
Don't worry,
did it a lot better than me.
instructors are patient enough to extend the sessions for 4 hours also sometimes. They won't end up in 2 hours exactly as they say.
Yeah, revision session we always have of 3 to 4 hours in between. So you can just relax and grab a cup of coffee also if you want.
Yeah, Ishant, go ahead with your.
But actually, we should not
week
take
four.
the misuse the opportunity, because many
No, we
people
have to thank them.
keep on asking the same like going very research based questions. So it is
Yeah,
wasting
it
the-
is.
Yeah,
I
so
think it is common intuitive after attending these sessions. Maybe just by seeing this all on notepad, we should understand.
Yeah, and I think we should make the effective utilization of the time also, because 184 people are waiting. So kindly be specific and be precise to the time also, because if you keep on dragging on one particular question to everyone, so we'll not be able to complete all the programs. So kindly,
That's why I'm
Okay,
saying.
see, if you are okay, see, if you want me to, just write these things and go on, keeps on explaining. You have already did these things in Usha ma'am's lecture, and I don't think there is anyone better than Usha ma'am to explain you all these things. We are here for some interaction. Like there are some students who don't get it that way. They want some different way of understanding the same thing. So that's why we covered one concept. We are doing some interaction, and now we'll move to the next concept. Okay. So
Yes,
yeah, I can see
sitting in
3
this is
raised
better way.
hands for now. Himanshu Dikshit, you have any other doubt in this?
Also, sir, these type of questions can
No,
be
sir, not at all.
all the previous session. They have solved all the live sessions which are on YouTube itself, and they can also solve from the Google itself. These are the basic queries, and here are some
These
qualifiers students.
So these are the basic for you, right?
And so,
some of the people are there, they didn't even understand from after seeing these videos. So it will be better to go ahead with Ishan. Ishan is what is solving. Ishan is what doing. Go ahead with this, and after all, we can keep the sessions afterwards for the discussion. Yeah.
Very true. Very true.
Who is speaking? Who is that guy?
Kranti Gaurav sir. Good evening, Ishan sir.
Okay. Yeah, good evening.
Sir, sometimes I got confused between ratio and this.
Okay, we are going through that thing. Okay. Yeah, just covered descriptive and inferential. Population sample. Okay, we have covered 4 things for now.
Right, sir.
Okay. Yeah. Moving on to next thing.
So,
Yeah,
sir, for inferential statistics in this course,
Hmm.
basically, if we are inferring something about a population from a sample, that is the only case we are going to call it inferential. If it is like we are predicting something in future based on past data, that is not what we're going to call as inferential. Is that correct?
Yeah.
Okay, thank you.
Sir, I remember
repeat
that
once more
it
time.
was, one second. I remember that it was told that inferential statistics is not in the scope of the course. Am I correct or?
Yeah, inferential statistics you will cover in statistics too.
Okay.
Here we will mostly
Then
speak on
let's not
descriptors.
debate on this. Let's move on.
Yeah, but you should be clear with the concept. Like if I
Not
you should
required. No,
generalize
when
it.
it is not in the scope, why should?
No,
why
but
should
we
I-
have to identify,
not
right? We
a
have to
scope.
You
identify
have
whether
to
If it is a
identify.
concept, one minute.
It's a,
If it is a
it's the
concept,
foundation.
so we should understand. Na? You know better. That's okay. But everyone not know. Na?
No.
Yeah.
It was
there are
because of the
marks.
time.
There are marks
Okay.
that
There are
are
time
awarded for
constraints.
identifying it.
Let's not.
Go into that. Okay. Let's not go into that.
Sir, please
Okay.
repeat once more time descriptive and inferential, then move.
Have you just joined or you didn't understand this?
I a little bit confused in a inferential status.
Okay, see, I have data. I have 2 crore students appearing for an exam. All right. It is not possible for me to get the data of these 2 crore students. So I select a data of few lakh students, which are feasible for me to collect. Okay. By using this data, I concluded something about my complete population, which is of 2 crore people. So that's inferential statistics.
And the descriptive statistics performed on only on population. No, sir?
You can perform if I am performing. This is my sample data. Okay. If I am describing this sample data, like average of this data is 76 marks, maximum is this, minimum is that descriptive statistics. If I have population data, for population data, I can also describe like average is this, maximum is this, then that descriptive data for population. So we can do descriptive on both sample and population. But for inferential, we draw some sample and conclude about my population.
Okay, sir.
Okay. So next thing we can move forward is variable and cases. Suppose some data is given to us. And you all must be careful with selecting what are the cases and what are not. Okay. Let's say there is roll number, there is some name, and there is some marks. Okay. Use different pen. Marks, let's say 20, 50, 45. Okay, so you see the first row, or you can say the heading of the column, which is roll number, name, and marks. As you see, if I take any of it, right, if I consider roll number first, the value of roll number keeps on changing. First it's 002, then it changes to 075 for next row, and in next row it changes to 256. So you see that value of roll number keeps on varying. So we call it as variable. Similarly, name is also a variable because value of name also keeps on varying. First it's A, then it's B, then it's C. Similarly, marks first is 20, like it keeps on varying, right? But cases, okay. Cases you must be very specific to select. Like each case should be a representative of a row. Or you can say of only one row. Okay, each case. Okay, if here I take, let's say my names are not ABC, it's A, B, and A. 2 people have same name. Okay. If I take name, each name as a case, each name, which means A, B, and A. Okay. If I take these as my cases, so you see, whenever I say the name B, okay, I know yes, I am referring to the second row. I can uniquely identify it. But when I say name A, in that case, I don't know which row I am referring to, whether I am referring to the first row or to the third row. So name is not, each name is not a case. Like A, B, A, it's not a case because it cannot represent uniquely each rows, right? In that case, we can switch to the roll number. You can see whenever I say roll number 002, yeah, I know I'm talking about only row 1. If I say roll number 256, I know we are talking about the last row. If I say 075, I'm talking about the middle row. So you can see that each roll number can uniquely make me identify each row. So we have to take each roll number as cases in that case. So here cases will be 002, 075, and 256. Okay.
Sir, in a general perspective, can we take the leftmost one?
Sir, I am some doubt of cases are observation.
1 minute, don't cut him. Let him speak. Yeah.
Hello.
The person who is speaking before you.
Sir, I am some doubt of cases are observation.
1 minute. Don't cut other persons. Let him speak first. He was speaking. Yeah.
So can we take like the leftmost column will be the cases in a general regard kind of thing?
This marks?
No, the leftmost.
The leftmost column. No. It's not like it is possible that you may get data where name is the leftmost column, then roll number, and then marks, right? So don't make it only the leftmost column.
So sometimes even telephone numbers also will be the unique one, so we can take that from the case kind of thing.
Even in week 1 graded assignment, if you have solved, you have seen the leftmost column is not the cases. The second.
I solved that one, sir. That's why the second one I got the wrong answer. That's why I'm asking this question, sir.
Cases must be different and unique.
Cases
sir,
is
can
just
I
like
respond to the question, sir? So he was asking that whether telephone number can be a case, but another property of a case is that the case should provide information about, like we are taking the roll number, it provides name and marks. So that's why we can take roll number as case, but from telephone number, I don't think we cannot get information like that, we
we should be able to gather information also.
Just correct me, sir, if I'm not whole. That's why I think cases should also provide information of the following. That was told, sir, in previous lectures.
If you take telephone number as cases, it can also be repeat, right? If there are, let's say, 2 students who are brothers, let's say, who use they have a common landline in their home, they will be sharing the same telephone number as well, right? So you cannot also consider it as case in some sense. The most efficient here is the roll number only. It will never repeat. Even if you have another student can also have name B, but it will definitely have the different roll number. Roll number won't be repetitive over here.
Excuse me, sir.
Yeah.
Sir, so cases are actually a primary key of data.
If you know DBMS, yeah, you can say primary key.
So it represents a particularly unique data.
Yeah.
Unique kind of list or record.
Yeah, uniquely. If I have cases, suppose if I have this table, okay, I have some, here we have only 3. If I have, suppose, 10,000 observations. So if I search by name, there will be many names repeating. I won't be able to get the exact row I need. But if I search by roll number, I will definitely get the exact row which I need. So yeah, cases help you look through the data completely.
Okay, sir. Thank you.
I have some confusion of cases are observation. Are different or same?
Cases and observations are same.
Okay, sir.
You can say it, sir.
Sir, here will be case or not then?
It won't be case, because if I say A, right, you are not sure whether I am talking about first row or last row. So each case should be representative of only 1 row. Here it is not. It is representative of 2 rows. So it won't be cases, right?
Then then name column will not will be case then.
Yeah, it won't be a case in this case.
Okay.
But if names are also non-repeating, okay, let's say it's ABC, you can take
as a
any
case
of that case. But yeah, I will still prefer roll number, because roll number won't repeat even in the future. If I keeps on adding more observation, it won't repeat ever, right? Name can be repetitive. Suppose a new student joined with name B.
Yeah, hello. Hello.
Okay.
Okay, yeah, now Prashant
Hello.
will continue from here. Okay. Yeah. Yeah, Prashant.
Yeah, yeah. Am I audible? Yeah, okay. Thank you, sir, for continuing the session. Okay. Okay, is my voice clear to everyone?
Yes, sir.
Yes, sir.
Okay.
Yeah, it's clear now.
So, you were on the cases and variables. Okay.
Yes.
So I hope concept of variables and cases are clear to everyone. Okay.
Yeah, yes.
Okay. Hello.
Yes,
Yes,
sir.
Yes,
Yes,
sir.
sir. Can hear you.
Yes, sir. Yeah. Okay. Okay. Fine. So describe the what is population and sample.
So can you mute centrally because we are having so much traffic.
Yeah. Yeah. So I have explained population sample. Okay. And answer have also explained variable cases. Okay. So we will continue from the structured data. Right. So I have explained that structured data is something which is in a predefined manner type of things. Okay. And unstructured data is something predefined manner. Suppose this is the data. Okay. I'm saying there is 4 students named A, B, C, and D, and courses from Math 1, Stats 1, CT and Python. Marks is this. Okay. This is called from where you can easily analyze information. Suppose I'm saying, tell me the course of student B. So you can easily tell me the B has stats. And unstructured data something. Suppose I'm writing in like this: A is a student which obtained marks is 72, and B is a student who suppose stats 1 and marks is 65. Okay. Similarly for C and D. Okay. And this is called the unstructured data because I'm saying tell me the marks of the student B. So you have to put more effort. Like you have to read one line, second line, and third line. After that you will get the B has scored 65 marks. Okay. So unstructured data is something which is not in any defined manner, any defined format. Okay.
Yes, sir.
This one type of is clear. Okay. So variables and cases are clear, right?
Sir, I have a doubt in previous.
Yeah.
Yes. Sir, suppose in course column, if some data is not given, like mathematics, statistic 1, CT is not given.
Okay.
Then what we call this? Sir?
Actually, this structured data, you get the C has not opted any course.
Yes.
Right.
That means if data is
structured
not.
Data is something.
Yes.
Yeah. Structured data is something where suppose you are very search the information. Okay.
Yes.
While in unstructured data, you have to put more effort to search the information, observe your data.
Okay. Thank you, sir.
Okay. Yeah. Thank you. So topic is data has 2 types also, categorical as well as numerical. Okay. So category is qualitative in nature. It will be qualitative, it will be quantitative, right?
Yes.
Categorical data is something where you are defining some category like okay, and category like poor, good. And quantitative data is something where you suppose 10, 12 like this, and you can meaningful mathematical operation on the data. Okay. So another example for qualitative data can be like you say blood group. Okay. Here you have category like A negative, B positive, B negative, like this. Okay. And quantitative weight, you can say height. Okay. On weight of a bike, you can say.
So your voice is breaking again, sir. It's not proper.
Yes, sir, it's not proper.
Yes, sir.
Sir, if you don't mind, can we continue with Nishan, sir? I mean, it is nothing personal. It was more to be, better utilization and getting a smoothness into the lecture. That's the purpose, sir. So if if Nishant is available, can we continue with them? It's a request, huh?
Okay, let me talk to him. Actually, I think there is some.
Only because your voice is breaking, sir. Nothing else.
Yes. One second. No worry. Yeah. Yeah. Hello.
Yes, sir, we can hear you, but still breaking a lot.
Okay. Questions are also he will come. Okay.
Hey, so yeah, I will be continuing today's session. Okay.
Thank you so much, sir.
Thank you, sir.
Yeah, thank you. Thank you.
Okay, so we have covered, I think, population, sample, descriptive statistics, inferential statistics, and structured and unstructured data, right?
Yes, sir. Yes, sir. Variable and cases also, sir.
Yeah, variable and cases.
Variable and cases.
Okay, so yeah. Okay, so data in general can be we can divide it into two categories. Okay? One is categorical, and other one is the numerical. And within categorical, we can divide it into nominal and ordinal. Okay, so if we go into discussion for that, so categorical variable is where my data is divided into different categories, right? If I have to, let's say, check out the income source, right? Source of income of my, you can say India, okay, or any country, and this income amount you can consider. So source of income can be healthcare, right? Agriculture, or sports is also a source of income, and there could be many. So here, if you focus only on the variable source of income, so you see that there are different categories: healthcare, agriculture, sports. There could be many more, education and all, right? So whenever there are such categories and I can divide my data into these categories, such data comes under the categorical variable. Okay. Within this data, if you look at the different categories, right? There are different categories are healthcare, you can say education, agriculture, and sports. In general, you cannot order these, right? You cannot say that healthcare is greater than education or education is less than agriculture or something like that. Okay, you cannot do things like that. So we cannot order these categories. Okay, there is no meaningful comparison between them. Okay, these all are just categories which we cannot order in some sense or cannot compare in between. Such type of categorical data lies in the nominal. Okay. But there are also cases where you can order the categories. If you go to some restaurant and they ask for your feedback about, like, rate their service, and they ask you something like that: bad, average, poor, excellent. Okay. So these are also categories, right? These are, you can say, ratings, and against it I have number of customers giving them that rating. Okay, I have something like this. So here you can see you can order this category, right? You can order it something like that. Great. Excellent. So these category I can order. I can compare in sense of the ordering. Like this one, poor, like bad is, okay, let's not include this one. Like bad is will always be less than average, and average is obviously less than excellent. So whenever we can order those categories, it comes under ordinal variable. Okay. And if we go into the numerical, we have discrete and continuous. Oh, sorry, no. It's interval and ratio. Interval and ratio.
Sir, I have a doubt in ordinal data. Can I ask?
Yeah.
Like if like in poverty line, suppose if given like 0 to 4 lakhs is in poor category, 4 to 8 in middle level category, and above this is, that means this is also ordinal data.
Yeah, it is also ordinal. You can order them, like 0 to 4 lakh earners will definitely be below 4 to 8 lakh.
Yes, yes.
So you can order it. It will definitely come under ordinal.
Yes, thanks.
So serial number in a data table.
Serial number is
it
not a
ordinal?
variable. Okay,
Serial number is not a variable.
It's not a variable. We don't consider serial number as a variable. Okay. Okay, so moving on, interval. Yeah. Interval is, here we have some numeric values. Okay, and we can perform some meaningful addition and subtraction operation over here. And also interval is same between the two observations. So you can say the interval is somewhat meaningful. Okay, if you have ever rated some app on the Play Store somewhere, they ask you to rate in terms of stars, right? 1, 2, 3, 4, 5. So you can see that here you can differentiate, right? Someone giving 3 stars and someone giving 1 star. I can definitely say that the person B has given 2 stars more than person A. I can do that addition subtraction operation. And also we assume that the difference is same between 2 star and 1 star, 3 star and 2 star, 4 star and 3 star, and so on. We assume the difference to be, this interval to be meaningful and same throughout. Okay, but what makes it different, what makes ratio different from this is, here we have absolute 0. So if there is an absolute 0, we can do division and multiplication operation as well. All right. So for absolute 0, you can consider it. General example you want, it would be just.
If this rating scale is having 0, will it become ratio? Rating 1, 2, 3, 4, 5 is having 0, 1, 2, 3, 4, 5.
Yeah, I'm correct. It will become, yeah, if it has 0, it will become ratio. If I talk about marks in percentage, it has an absolute 0. 0% means absence of marks for that person, right? That will also comes under ratio scale. And if someone scoring 40 marks and someone scoring 80 marks, so I can say that person B has scored twice the marks scored by person A. I can do some division multiplication thing over here. Okay. And what does absolute 0 mean over
sir?
Yeah.
Sir, just one, like you said that when there is a 0% mark, it means absence of marks. So if in rating, though I haven't seen, if there is a 0 rating, it means the absence of rating. So then we can say it's a ratio scale of measurement.
Yeah, 0 means absence. You can say.
Okay. Okay. Thank you, sir.
And what is an
Also take
absolute?
a temperature example, sir.
The temperature example. Okay, temperature in Kelvin. You can also consider. Okay. Temperature.
Getting back to marks itself. Is percentile kind of thing will be coming under ratio or interval, sir?
What thing?
Percentile, sir. Percentile.
Percentile.
Not percentage. Percentile.
Percentile. Okay. I'm not sure on it, but yeah, you can consider it.
So please.
Sir, I have a doubt. Sir, if there is a question like percentage is what kind of variable, right? And the options are interval and ratio. So, so we have to tick both or only ratio?
You have to take only the ratio.
Okay, I saw some questions where, okay. If it is the higher one, then we have to tick the higher one, right? Though it is interval also, right? The ratio scale is.
No. See, there is an order. There is this order: nominal to ordinal, ordinal to interval, and then interval to ratio. So what nominal is you can see the first mode or the basic one, like this example over here. Ordinal also has the property of nominal, but in addition, you can do the ordering over here, ordering of categories.
Okay.
In interval also has all the properties of nominal and ordinal. In addition, you can do these mathematical operation over here.
Right.
Ratio, it has all the properties of all three. In addition, it has absolute 0. And division. If question is like you can only do addition and subtraction, if these are possible, right? Then what could be the possible scale of measurement? In that case, it would be interval and ratio.
Interval and ratio both. Okay.
So you have to think.
So
like
how
that.
come the currency note comes under ratio scale of measurement?
Currency
note.
Yeah, currency note or currency, you can say it will be amount in your bank, is something like that. Your bank balance, you can say it would be ratio scale, because 0 means absence of any money in your bank, and obviously someone having 40k in their bank is obviously twice than someone having 20k in their bank. So it comes under 0. It has absolute 0.
And it also comes under interval scale of measurement.
No, it has absolute 0. It will come under the ratio scale. Ratio all has all the properties of interval, right?
Sir,
day of week.
So temperature Kelvin you said, that is in 0, right?
Temperature in Kelvin, it comes under ratio scale. Yeah. Okay, so let me
What
tell
is the
you
difference
about
between continuous numerical and this discrete numerical?
one moment. Okay, so if I brief you about absolute 0, how to think on it. Okay, so if I take the rating of this, let's take this 1 to 5. Consider this scale 1, 2, 3, 4, and 5, right? And if for another thing, let's say the marks over here, right? 0, 20, 40, and keeps on going 60, 80, and some 100 over here, right? So here, if you see someone giving rating 2, okay, so difference between rating 1 and 2 is only this much. But someone giving rating, let's say 3, right? Or you can say, let's say giving rating 4. Okay. So if you see, in general, 4 should be twice the 2, right? But here it is not. Here you see, for going till 2, I have to travel only this much. But for going to 4, I am actually traveling thrice as much. I need to travel for 2. But in general, it should be twice the 2. So we cannot do this division multiplication operation over here. But if you talk about in terms of marks, which I said to be ratio, someone scoring 20 marks is this much interval. And someone scoring 40 is exactly double the 8, right? Which it should be. Like 2 into 20 should be 40, right? That's what the absolute 0 plays the role over here. Okay.
But in the case of currency, sometimes we'll be having negative amount also in our banks.
Oh yeah, we don't consider if it is mentioned that you can have negative balances, then it will go to interval, not in ratio. Like if you remember graded assignment question, if we have negative marking, it will be interval. If we don't have, it will be ratio, right? So it depends on your observation sometime also whether it should be interval or ratio.
Sir, but one standard thing in ratio scale of measurement, I don't think we have negative value. The lowest
in
value
ratio
is 0.
Zero. In ratio, the minimum is 0. It can't go beyond it.
Thank you, sir.
Sir, day of week, what scale would it be?
Day of week, it will be coming under nominal, I think, categorical variable.
So, so are we putting it in nominal because day of week has an order like Sunday,
No,
Monday,
it don't
Tuesday.
have order. You cannot say that Sunday is greater than Monday. You cannot order it, can you?
Sir, there is the order in the sense that Monday comes after Sunday, but it is circular. It is a circular order. That
it is circular order. I cannot say that Sunday is greater than Monday, or you cannot say that Monday is greater than Wednesday.
Okay, so that's why we are putting it in nominal, not in ordinal.
The ordering should be meaningful.
So in date, where would we put date? Like 3rd of Jan 2020.
Dates also we put under nominal. We can't say that 3rd Jan is greater than some 10th Jan.
So but here there is no circular thing, and there is an order, right? We can say before and after.
There is not. Yeah, that's some time series data before and after. You cannot say that it is greater than this, right? You cannot do something like we did in poor.
But it is order only about like greater and lesser. It's not about before and after.
Yeah, it's only what you should do. You should be able to, do some meaningful ordering. Like you should be able to say that product A is greater than product B, something like that.
No, we often order a particular set of person based on their date of birth, right? So that is ordering based on date.
If I am talking about age, it will come under definitely ratio scale, straightforward. But if I am talking about only date, it will be nominal only. So it depends
the date
on
of joining.
Data.
If I'm not talking about age, I'm talking about date of joining, right? That is also an order.
Date of joining, that's different. If I talking generally about the dates, it's something else. It also depends on the data I have.
Yeah, so it depends on the how date is being used in that particular set of data. Right?
Yeah, you can't generalize things like that.
Okay.
Sir.
Yeah.
Sir, if interval is not same but meaningful in rating, is this interval or ordinal?
It would be same. It should be same. Intervals are same, and you will not see any such kind of complications in this course for now.
Okay. Thank you.
Okay. Moving forward, we have one more.
Hello, sir.
Thing. Yeah.
Sir, I have one doubt related to sir, the jersey number and the phone number related to which variable or cases means. I little confused in that.
It depends on the data table we have. You can't generalize that it will always be a case or value. It depends on the data you have. Okay. Moving forward, we also have two more things in numerical, which is discrete and continuous. So discrete is it only takes some specific value. Okay, let me say there are 10 MCQ in an exam. So number of MCQ attempted by someone, it could be either 0, 1, 2, so on up to 10. Okay. So if you take any two value, let's say I'm taking these two consecutive values, it will take either 1 or 2. It cannot take any value in between. It cannot take 1.12 questions done by me, 1.25, or it cannot take any other value in between. So such things comes under discrete. But if I talk about marks in percentage, okay, if I take any two consecutive value, right, 50 and 51, in between these two, I can take any value, right? this value is also possible. If I take these two, between these two also any value is possible, right? And then again between these two is any value is possible. So it has infinitely many values between two consecutive observations. So such numerical comes under continuous. Okay.
Sir, I have doubt over here.
Yeah.
Sir, in discrete means we need to, मतलब sir ज़्यादा maths calculation discrete में नहीं करना पड़ता है क्या? कि continuous के comparison में कि वैसा रहता कुछ?
It's not something like that. It's if you go in the stats too, there is you will be using some integration and some summation. So yeah, for continuous we have to consider all the values in between these two, right? Each and every value. For that we use integrations.
Yes.
But discrete we can simply do the addition. We don't care about any other values because we know that's the only value we have. So discrete sometimes is easy to handle. Okay.
Excuse me, sir.
Yeah.
Sir, so discrete values are kind of a set of whole numbers.
No, not whole numbers necessarily. You can if I have, it can take only this much value. Okay, 1, 1.1, 1.2, 1.3 up to 1.5 only. This is also discrete. I can have either this or this, no in between value.
Okay, so sir, it is the value of given a set of given values. We are given a particular data, so there will be no value in between.
Yeah, you can say that. You have to identify it. Okay.
Sir, just can you repeat once more? I just couldn't understand that how 1.1, 1.2, how it can become discrete. I believe 1, 2, 3, 4, these are discrete. No, sir.
No, this is also discrete. Either I can have 1 or 1.1. I could have any of these 6 value, right?
Okay,
I cannot have any in between value between these two.
Okay. Yeah. Okay.
Right.
Understood.
Can we say that runs scored by Indian cricket team comes under numerical discrete numerical data?
Yeah, you can say that.
Okay.
So the marks obtained by a student, right, in 5 subjects, the total of that marks, it is discrete, right? But when we take out the percentage of that mark, we say that it is continuous, even though for every given mark, like 467 would translate into a specific decimal number. 468 will again translate into a specific decimal number, and there won't be anything between those two decimal numbers, right?
Yeah.
So those percentage are also kind of discrete because they map to discrete numbers, discrete total numbers, right? But we usually treat them as continuous.
Yeah, percentage is continuous and the marks will be discrete.
But in this particular scenario, those percentage, even though they have decimal number, they have only the percentage can be only certain set of that decimal numbers, right? That corresponds to the whole number.
No, we do it. We just, to print it, we do it. But in general, it can be anything. It can be 40.681%. We round it off to 40.68. We do the rounding off.
467 out of 500 and 468 out of 500. If we translate them to percentage, whatever percentage they comes, right? There is no other percentage value that can come between them, right? Because if 467 and between 468 there are no other mark, you cannot have a percentage that is in between them.
Yeah, but here we don't know the total marks and all that. We just assume we round it off. Even if someone is scoring, there could be partial marking also, and a lot of things are possible. So if someone is getting 40.687%, we round it off to 40.69, but in general, this value is also possible. Or you can also break it. You can also get some scenario where it would go like this, right? 6666. You can say if you do 100 by 3, you will get 33.33 and it will keep on continuing.
Okay.
So yeah, percentages, we consider it as continuous. Okay, that's it with the week 1. Any doubt in this?
सर ये नॉमिनल स्केल में मतलब कि वेट अ मिनट jersey number and telephone number comes under nominal scale, sir.
Yeah. Okay. We cannot say jersey number 7 is greater than jersey number 5.
So
there is nothing meaningful in it.
There is a missing topic. You missed the topic. Cross-sectional and time series data.
Cross-sectional time series data. Okay, yeah,
Yes,
do that also.
Summarize and after that move on to it.
Cross-sectional and time series. Okay.
Excuse me, sir.
Yeah.
Sir, weight of a truck comes under continuous or discrete?
You
Continuous, I
tell.
think.
Why continuous?
Continuous, okay.
Yeah, why continuous?
Sir, on
Because
the
it
basis
can
of
take any weight.
Yeah, it can take any weight. Yeah.
sir, if an value is having unit, then it should be in continuous or discrete.
Having unit doesn't makes it any difference in that. Anything can have unit. Weights can have unit, but it's continuous, right? Anything can have unit and still can be both. It's not something to be done with the units to differentiate.
Sure, thanks.
Okay, yeah. Time cross-sectional and time series data. Okay. If for at a moment of time, like at this moment of time, I am gathering everyone's some information. Okay, this is their name. I am gathering everyone's roll number or something like that, or some other information you can say XYZ. Okay, so I am doing this at this moment only, and I am doing it for everyone, right? So such data comes under cross-sectional. But if I keep on doing this data, right? Okay, let's suppose I selected one student, okay, at random. I collected some information about him at, let's say, 7 p.m. I noted down. Again, I did at 7:30 p.m. Again, I keep on doing it a few more times at a regular interval of time. So such data comes under time series data. If I am repeating that observation again and again at regular intervals of time, that's time series. But if I am doing the experiment at a particular moment of time for all the observations, that comes under cross-sectional.
Sir, I have a doubt. In that case, the data set, any given data set will be either a cross-sectional or a time series data, right? No third option.
There are third option, but that's not in the cross. Yeah.
Okay.
There are things when we do double, because in your time series data, we observe only one thing.
Right.
But if we can also do multiple things at multiple times. So that's something different. Yeah.
Okay. But for our purpose, either it will be cross-sectional or it is time series.
Okay, yeah. So just a general question, if I am, let's say, recording the price of, let's say, USD, or you can say INR, like how much one USD weighs in INR every 3 hours. What will it come under, cross-sectional or time series?
Time series. Time series.
Okay, if I am, like there are, let's say, suppose different ice cream parlors, okay, and I am taking a note of the ice cream they all have. Like, let's say there are 3 different ice cream parlors, and I take a note of them. Like, okay, let's say this flavor ice cream is this much, this flavor ice cream is this much. It will come under cross-sectional or time series?
Cross-sectional, sir.
Cross-sectional.
Okay, agree. Okay. You can expect in the qualifier.
Thank you, sir. Thank you.
Okay. Any doubt in week 1?
No, sir.
No, sir. Move on, sir.
No, sir.
Move on to week 2.
Sir, excuse
Yeah.
me.
Percentage, sir.
Can we go to the first slide where you have mentioned the absolute part? Absolute zero.
No, I can't, but yeah, I can draw it again. Okay, if you have rating 1, 2, 3, 4, and 5,
Okay.
so 0 marks, 20, 40, 60, 80, 100. So for going from rating 1 to 2, I have to travel only this much, right? And for giving rating 4, I have to travel this much. So you see, to give rating 4, I don't have to travel twice as rating 2, right? I have to travel thrice as much, right?
Okay, right.
So that's not something meaningful division or something, right?
Okay.
But here, if you see, for to get 20 marks, I have to travel this much, and to get 40 marks, I have to travel just a double, which makes the sense.
Right.
So that's 0 is the absolute 0 here.
Sir, 0th percentile means that is the smallest value in the distribution, sir, isn't it?
Yeah, 0 here means the absent of marks for that student. If you talk about another example, you can say that temperature in degrees Celsius, right?
Okay.
It can go till minus 273 degrees Celsius. 0 over here, 20 and 40, right? To reach till 20, you have to travel this much, right? And to reach till 40, you have to travel this much. You cannot say to reach till 40, you have traveled twice as much as you need to. So it don't have any absolute 0 over here. Absent over here, right?
Percentile, sir,
Percentile.
Percentile. 0th percentile means that is the smallest value in that particular distribution, right?
Percentile won't come under the ratio. I think it's not something good. It has something to do with the order of the students.
Does it depend on data, sir? Like,
yeah, it depends on the data. More we cannot generalize.
Yes, sir. Someone.
Yeah.
Can you put it in discourse, sir?
Sir, 0 percentile is possible.
As percentile, it's not something to do with your marks. There is some ordering in it which we are labeling. Right? There is some different pattern over there going. You cannot say it's the ratio or something.
Yes,
cannot generalize it.
J means is there is negative marking, but still we got something percentile.
That has to do with something order, not your performance at all.
Yes, sir. Yes, sir.
Okay,
Got
moving forward to.
Can we ask this question in discourse, sir?
Yeah, you can just give the data also, because looking at the data, it would be
sure.
Good. Okay, so week 2 is mainly focused on categorical data. Categorical data over here. So let's, first concept is of frequency distribution. Let's say, give it rating and number of customers over here. So suppose there's a restaurant where people come visiting and they give you a rating. So first one gave, let's say, poor, next one gave good, next one gave excellent, then again someone came and gave excellent, good, poor, and again excellent, right? So we can draw a table, frequency table, where we can this data is some way, if you have 1,000 customers, such data you won't be good to analyze or read. So we transform it into the frequency table, or we say it as frequency distribution. So let's say it's poor over here, good, and excellent. So we just do the normal counting, like how many poors we have. We have 1 and 2 over here. Similarly for good, we have 1 and 2 over here. And remaining we have excellent, right? So this is what we call as frequency distribution of the rating over here. Within this, another concept that comes off is relative frequency. Okay, so relative frequency is we take the total over here. Total you see is 7. So relative frequency for poor will be the frequency of poor, which is 2 divided by 7. Similarly for good, it will be 2 divided by 7. It will be 3 divided by 7. And always remember that sum of relative frequency would be 1 always. Okay, so if there is a question like that, you are giving some, let's say, rating over here, poor, good, excellent. Frequencies are not given to you. Only 2 relative frequencies are given to you. You should be able to find the third one because you should know that sum is equals 1, right? So that's why it's important to know that sum of relative frequency equals 1 over here.
Is this relative frequencies are nothing but proportions of
Yeah,
total?
but proportions, yeah, of total, you can say.
So how to go to solve it? Can you have the example?
Can you repeat?
But sir?
Can you repeat?
Oh, so I'm asking for how to approach for solving this equation. I mean, when we know relative frequency, but we don't know the frequency, can we
Okay.
have any question?
Here I am saying that you have the risk rating, right? Poor, good, and excellent. You don't know the rating. You don't know the frequency over here. Okay, it's missing, and you only know the two relative frequency, and you have to find this third one.
Yeah,
you can do it, right?
I understood, but what I want to know is how to find it. What is the process of finding it?
Relative frequency.
Can we have a numerical? No. The frequencies which are not given here in this section, in that orange one.
For that, we need this complete data.
Formula, sir.
We need this complete data to know about it.
Can we take one question on it? If time left.
Okay.
We solved many questions in GA graded assignment also. We
What
solved.
kind of question you want? Like, I'm not getting it. If these frequencies are not given, I don't know the total. I won't be able to compute it.
So there are already some questions like this kind in graded assignment. So
in such question, some
one
information are given where you can do that. Like, okay, there are some questions, right? Let's say we have three categories, A, B, and C. Or let's say you know that 20 over here, 0.2 over here, and 0.1 over here, X, Y, Z. You have to find this. You are asking such type of question, right?
Yeah, correct.
Okay. So we know that relative frequency is frequency upon total, right? So
yeah.
If I look at the second row, I know the frequency and I know the relative frequency, right? 0.2 equals 20
right,
upon
right.
total. From here, I can get the total number of observations I have, which is nothing but 20 over 0.2,
yes.
or you can say 100 observations I have in total, right? Once I get this total, right, I can find the frequency of X, because for X, for this A also, I know that relative frequency is 0.1, frequency is X, and total is 100, right? So X equals 0.1 into 100.
Yeah, so it's a matter of calculation, and we found that it will become 10.
Yeah, and once you find X is 10, you know total is 100, you can find Y is 70. And here you know the sum of relative frequency should be 1, so 0.7, straightforward. So there will be sufficient information given to you, but the only formula you have to use is this thing, and sum of relative frequency is 1. These two will solve all your problems of such tables.
Okay, so that's what actually I want.
Yeah. Okay. One minute. Yeah, moving on to, we have, this one is clear, right? We can move to pie charts and all those other charts, right?
Yes, yes.
Yes, sir.
Yes, sir.
Okay. So yeah, in general, we can start with the pie chart.
Sir, one question. There will be no question regarding this Google Sheet, right? Because a lot of lecture regarding Google Sheets also.
Now, Google Sheet is just to give you an experience. You won't be allowed to use Google Sheet.
Okay. Okay. Thank you, sir. Thank you.
Okay.
So
we have,
Google Sheet, are they required in future, like in statistics 2 or something?
no, in statistics 2, we will be working on a bit Python, but no, you will just have to use a calculator only.
So no Google Sheet is required in future either, right?
No, yeah. It's just to give you an idea of how we work in real life. In real life, you want to use a calculator for sure.
Okay. Okay. Thank you.
Okay. So pie chart. Okay. Whenever we have some data like it, okay. Let's say we have some categories over here. and some frequency over here. Okay, or you can say some relative frequency over here. A, B, C, some random data you can assume. Okay. So pie chart basically gives me the proportion that each category holds. Okay. Consider this. This is category A, category B. So whenever I am interested in knowing the proportion that each category holds, we use the pie chart for that purpose. Each circle, if you notice the circle of A, this, it is proportional to its relative frequency or frequency, you can say. Okay. So yeah, in general we say it's proportional to relative frequency. So each circle, if whenever we are interested in knowing what proportion each category is hold, we stick to the pie chart only. But if there are, let's say, 50 to 60 categories, or even more than that, okay, in such cases we avoid pie chart, because you won't be able to show, you know, some 50-60 division in the pie chart. It will become really messy to read or something. You won't be able to read this if you divide it, let's say, in 100 parts. A small circle in 100 parts, you won't be able to read or get anything, right? Okay, so whenever there are large number of categories, we avoid pie chart. And whenever we are interested in knowing the proportion, we use it. Okay.
Sir, just one question. For a large number of categories, if we want to know proportion, then should we represent the data in a table where at least we can show it?
See, there may be some question. Okay, let me just, okay, there may be some question. Okay, let's say I give you, okay, let me just, suppose I give you this data, right? Okay, this is some categories, okay, and this is some frequency.
Yes,
okay, this, and I say that I am interested in knowing the proportion of each category. For that, you will have to compute the relative frequency and then compute the pie chart accordingly, right?
Yes, sir.
Okay. But what if I am not interested in the proportion? I am interested in the count of something.
So then we can go to bar chart, I believe.
Yeah, you can still use the pie chart, but it is not convenient to use over here, because pie chart basically shows us something in the percentage, it owns. Right?
So my question was, sir, if we have, if we are interested in understanding the proportion, but if we have multiple categories where the pie chart can be a little cluttered, so then can we use a table to show that proportion and all?
Yeah, see, these are some real life applications and real life troubles which you will definitely facing. And there are also various different type of charts rather than par, by, and Pareto, various charts. But in your course, we will only stick to that. For proportion, we stick to pie chart only.
Okay, sir.
Okay, in general, yes, you can use anything. You can even use bar chart to show the proportion, not an issue. But for this course, you will be sticking to only this, because it is the most convenient way.
Thank you, sir.
Yeah.
Here in the pie chart, these proportions we are converting into percentages, and we are showing only percentages, right?
Yeah, you can also show proportion. It's not an issue. It's up to you how you want to label.
Okay,
Yeah,
I have never seen.
Yeah, there are. Try to make it on Google Sheet. It will show you different ways you can label. You can also label count also there. You can also label count over here, but still we prefer not to go into
But
it.
these points, proportions, 0.1, 0.2 outside, normally I never seen these percentages and numbers. I have seen that.
Yeah, you can go on Google Sheet and make that out of 1. It will show you something decimals.
But in general, no, in general outside, no one shows these proportions, na, in numbers, 0.1, 0.2 like that.
It's up to their objective, like how they want to represent, they do it. Some people do it, some don't. It's up to everyone's preference.
So pie charts are in circle shape, right? So there are horizontal single bar charts that shows proportion. Those kind of charts are also there, right?
Yeah, I said there are many charts, but for this course, when we are interested in proportions, we assume that we go for pie chart because that's better way to, because each slice is nothing but proportional to the relative frequency or something. It gives us that yeah, it holds this much proportion of the whole data. So yeah, whenever proportion word we are interested in, we go for pie chart. Okay, but when we are interested in the count, or you can say the frequency of something, we switch to bar chart. So bar chart will be something like this. Let's say the category A, B, C. Okay, one more thing. If these data is ordinal, okay, let's suppose I have this order of categories. So this order should be maintained. It should be A, B, C only. I should not make it B, A, C, something like that. It would be wrong. The order should be maintained. Okay. And then we can draw it, and from bar chart we can easily see the count, right? If there, we can easily know that yeah, point B has, let's say, this 35 frequency or something. So bar chart is mostly useful for when we're interested in the count or frequency of the categories.
So sir, if the order is like BAC, right? So we can mark it as misleading chart.
Yeah, it should be maintained, but you won't be seeing such questions for now. So okay, yeah.
So ordinal data cannot have a Pareto chart, right?
Yeah, I'm coming to that also. Yeah. Okay. So Pareto chart, we basically arrange the bars either in ascending or in descending order. Both are possible. Okay. So suppose this is my ordinal data, okay, and if I arrange it in the ascending order, so it would be something like B comes here, then A, then C. So here you see, in ordinal data, my order of category should be preserved, which is not in this case. So for ordinal data, we cannot plot this Pareto chart. It should be avoided. If your categories are nominal, let's say these are, I have this nominal data which has categories X, Y, and Z, then I can definitely go for this Pareto chart. It's in descending order Pareto chart. Then it could be like that for nominal data. But if it's ordinal, the order should be preserved always. Okay.
Sir, one fundamental doubt, like when we are saying Pareto chart is also ordered and ordinal also it is ordered also. Now, when we have both the, let us say two graphs are given, that is both are in order. So is it how we can identify it is a Pareto one or ordinal chart?
In Pareto, you will have this either descending order or this ascending order. You will have some order like that. Okay. But for ordinal, we don't plot the Pareto chart. So yeah.
Okay.
We only stick to bar or pi. You don't go for Pareto over here.
So maybe in one bar chart, if it is there and that is in order, that also, let us say one bar chart is there and that is ordered like ABC. Okay. So that chart is given on the B option and A option is given the Pareto chart which you are making. So how we can identify which one belongs to which category?
You won't be getting such ambiguous questions. So,
okay.
Yeah,
Okay. Thank you, sir.
So sir, in pie chart also, do we need to maintain some circular order of the
in circular, there is nothing order, right? You cannot say that this is your first slice, this is your second, this is your third.
So A, B, C, D. For 3, obviously there is no order. For A, B, C, D, like 4 or 5, if we have pies, there can be a circular order, right?
There is no starting and ending point in it, right?
Okay, so we don't need to worry about order in case of pie chart.
Yeah, there is no starting and ending one circle, so you can go for A, B, C, D, like either anti-clockwise, clockwise, it doesn't matter. So nothing to worry about it.
Excuse me, sir.
Yeah.
Could you please tell about the possible calculation that would that was possibly come to calculate from data given in pie charts? How to calculate them?
How to calculate them? Okay, I think there is such question also in the graded one. You will be given some percentage. You will see such question in mock also. Let's say this is 25%, 15%, 15%, 45%. Okay, and category A, B, C, D, and we are given that there are total of 500 observations. So you have to tell how much lies in category A. So you see that 25% of observations lie in category A. So 25% of 500 is nothing but 125 observations lie in category A, right? From side, or you would be asked, but with the mode of this data. So mode is the largest slice over here, which is category D.
This type of question we can solve through degree, like a 360 degrees. The
360 degrees, like
by using degree, but 25%, 360.
Yeah, we do that conversion.
Okay.
From degree to percentage, you can do the reverse also. 25% is nothing but 90 degree over.
Yeah.
That's up to you how you go.
It depends on a question, yeah, something like it's my choice.
You in real life it's your choice, but it depends on how question is given to. If here degrees are given, you have to convert it into percentage and then go for this. So it's up to you.
Okay, thank you.
Yeah. One more thing in the bar chart, it is not necessary to have these categories on x-axis only. We can plot the categories over here and frequency over here and then make the plot also. Okay, so it's one and the same thing. You can do it either way for both bar and Pareto chart. You can do that. If there is a Pareto chart, you can plot it something like this, the decreasing order, right? So you can have categories on the y-axis and x-axis both. It's up to you how you want to plot it. Okay. After, are you clear with all three types of chart? Can you move to the
Yes, sir.
Misleading graphs? Okay.
No, sir.
Okay. So yeah. One more case we have is when we have many categories.
Sir, is histogram covered?
No,
Histogram is in week 3.
Oh, yes. Okay.
Okay. Yeah. So yeah, when there are many categories, right? As I mentioned, we can't go for pie chart, and there you won't be able to plot 100 divisions of this circle. Definitely, you can do it, but it won't be good visually. It won't give us some interpretations. Okay. So we generally do it in the bar chart. Let's say this is our chart over here, and then we have some others. This type of very small. So what we do is we club all this, okay, and make it to other category. Name is as other, and then we just plot the graph. So there is something like that. Do something like that. You can also do it for pie chart, but in pie chart we generally avoid because it's very tedious to do. Like here you will be having some 1%, 0%, a lot of it, right? 2%. You have to convert it all into frequencies, add them up, and then transfer it back into the percentage or related frequency. So it's kind of a tedious task to do. That's why we avoid to do this other thing in the pie chart. We only stick for this in the bar chart only.
So it is mandatory that we should combine the minimum level charts into other.
No, whenever there are a lot of categories, you won't be, don't want to look your graph something like that. It's kind of
Right.
not good visually. So we club it and make it the other categories.
Okay, so it is not mandatory. We can.
No, it's not mandatory. It's just visually how you want to make it look meaningful.
Sir, that the others one, na? So is it like we can add that into that, or is there any formula to include? Then only we can put that other. Let us say
You can add it.
big one is let us say 30, second one is 20, third one is 10, and let us say 5, 3, something like that. So we'll add that 5, 3 to 1, something like that.
It's up to you. That's how you want to do it. In real life, you will be having a lot of data. So you just have to see how you want to make it more representative visually, more attractive to your audience.
No,
So there is no hard and fast rule to do it.
Other wala, if I want to represent, so I will add all of them. Na, the small wala, I can add all of them and put into other. Yeah, is there any formula to?
No, there is no formula. There's no hard and fast rule. It's up to you how you want to make it look to your audience.
Okay.
There is nothing like you have to do this. Okay. Okay. So moving on to some,
Sorry, sir. I had a difficulty in one of the assignments in week 2. May I ask it? It's on relative frequency.
Okay. Which one?
Sir, the question actually goes like a cab driver got the rating as feedback from 20 customers on a given day, which are as follows.
Okay.
7, 9, 8, X, 6, 9, 7, 5, 9, 10, 7, 8, 9, 8, 8, 7, 10, 6, 6, 9. And the question says,
you have to find the value of X.
If the relative frequency of rating 7 is 0.25, then what is the value of X?
Okay. Okay, so in general, there are total number of observations are 20, right?
Yes,
and
sir.
If relative frequency of 7 is 0.25, they put it into the formula frequency upon total, then the frequency of 7 should be 0.25 times 20, which is nothing but 5, right?
Yes, sir.
So
but
if
the
you count 7,
answer that was given there was 7.
if you see in my whole data, there are only 4 7. But it is given to me that relative frequency of 7 is 0.25, which will be possible only if frequency of 7 is 5, which means my X equals 7. Only then I will be having 5 7s to make it possible.
Okay, now I get it. Thank you, sir.
Okay, moving
Sir,
on.
can we add?
Yeah.
Can we add one more difficulty to last question?
Okay.
Suppose if I don't know the total, instead of
Okay.
total, I know only a x variable here. Then how I will find the relative frequency?
I will count it at 20.
Okay, so you will count it as x plus whatever this number is.
Yeah, I will see that my first observation, second observation, third. So I have total 20 observation. I can count it like that.
Okay, so how you will get value of that x variable?
It is given to me, right? Relative frequency of 7 is 0.25. If it is not given to me, I cannot find.
Okay, no, I'm asking for the variable x. How you will find value of that variable?
That's what we did, right? Relative frequency of 7 is 0.25, which means the 7 must occur 5 times. But here it's occurring only 4 times. 1, 2, 3, 4. So my x should be 7. Only then frequency of 7 will be 5 instead of 4. Only then this relative frequency it will satisfy.
Okay, sir. Okay.
But the logic is very tough, sir. It will not strike so easily to the mind.
Yeah, that's why it's in practice. Now it will strike to you when you see such question again.
Okay, sir.
Yeah.
In the graded assignment 4,
we are not,
one question came.
We haven't reached week 4 till now. We are in week 2 only.
Continue.
Okay, I have question in biserial. When my biserial comes 0. minus 0.34.
We will cover that week 4. When we go to week 4, we will cover that. It's not from now. Okay, so covering week 2. Okay, area principle. By now you all must have know. Okay, that
Yes, sir.
if I have, let's say, this pie chart, right, and this is my category A, this is my category B. So the area the category A hold, right, should be proportional to the its relative frequency. Okay, or the area I'm mentioning. It should not be like I plot this. Okay, I label it as 35% as 65%. This is not following area principle, right? Because 65% cannot be this much area. It's even less than the half of my circle.
Yes,
So
sir.
such things you have to keep in mind. Okay, and also in bar chart you can have it. Okay, we assume that all the bars are of equal width only. Okay, if it is of unequal widths, we also say that area principle is not followed. Okay, let's say 1, 2, 3, 4, and 5. Because here what happens is this is the 1 unit, right? And generally the frequency is defined by the area of that bar. So 1 times 5, its frequency is 5. 1 times 3, its frequency is 3. But here if you see, it's the 3 units instead of 1. Let's say not instead of 1, it's 3 units, and it's 2 over here. So its frequency should be 6. But here it's mentioned as 2 only. So that's why area principle should be followed. As well, it will lead to misleading. Okay. Another thing we have is in misleading graph is missing baseline. Okay. So let's say I'm plotting this my data. This is my category A, B, and C. And it goes something like this. Okay. Here it should always start from 0, this point. Okay. If it's starting from some other number, let's say it's starting from 100, 200, 300, like that. In such case, we say that there is a missing baseline. It should always start from the 0. If it's not starting from 0, we say that there is a missing baseline, because it makes the graph a bit confused for the viewers. Because here if you see, the frequency of A is close to 400 and it's 200. But since our baseline is starting from 100, the difference between A and B seems to be significantly large, but in general it is not. If you plot it from 0, it would be something like this, which is close to A. So missing baseline can confuse the viewers by giving some misleading information, because your viewer won't be focusing on this. In general, they will be just looking at the size of bars and knowing that, yeah, this has a big lead over B. Okay, any doubt till now?
No, sir. No, sir. And one more, sir, manipulated y-axis is there.
Yeah, got that. So, okay, I think now Prashant will be taking over from here. Okay.
Yeah, hello.
Hello, sir.
Yeah, am I audible?
Yes, sir.
Very clear.
Yes, sir.
Thank you, Ishan, for continuing this. So, okay, let me share my screen. Okay, is my screen visible?
Yes, sir.
Yes, sir. Yeah.
Yes, sir.
Okay, fine,
Yes,
fine.
sir.
So, what topic have been covered?
Misleading graph.
Okay. From misleading graph, I have to continue. Okay, so see, suppose I'm saying, suppose I have bar chart like, yeah. Suppose it's around here, okay. So, suppose this is of any category A, and this is category B, and suppose I'm starting as 420 and it's 430, it's 440, around 490. Okay. So if you see here, suppose its value is around 489 point something, and its value is around, suppose I'm taking as 440. Okay. So from here, you can see, if you see, on seeing only the bar chart, I mean bars, so one can interpret like, yeah, it's this category is 2 times of this. Okay, but in reality it's not. Okay, so that's the something which is I mean missing baseline. Okay.
Yes, sir.
Fine.
Yes,
It's clear. Missing y-axis means, suppose I'm starting here 0 or 10, then again suppose I started around 30, then again started 32, 42, and continuing up to on the interval of 2 2. So this type of graph called misleading graph, manipulated y-axis. That means here y-axis has been manipulated. Okay, because there is interval of 10, again it's going to interval of 20. Here I have manipulated the y-axis, and from here it's continue on the interval of 2. Okay, so this type of manipulation called manipulated y-axis. Okay. And suppose,
yes, I got it.
Yeah, suppose I'm no giving any break. So this is not manipulated y-axis, because I'm mentioning that I'm making some break here. Okay.
Yes.
Okay, so mod and median has been covered or not?
So round of error, sir. It will be topic.
Round of error.
Yes.
Okay, so thank you. So let me complete the round of error. So round of error occur in pie chart. Suppose there is pie chart, and it has 2 category. Okay. Suppose like it is around 51.2 and it's 49.8. So I think it's 100, right? It will be 100 plus
More than 100, sir. It will be 101.
Suppose it's a 50.2.
101.
Okay,
Now it is correct. Now it's correct.
Okay. So suppose suppose it's around 49.5 and I'm taking as 50.5. Okay, and I have rounded off as it's as 51. Sorry, it's 50 and it's as 51. Okay, if you sum up this, so it will be 101. Okay, that is something called round of error. Means round of error occurs means if you add the all these slices, then it's not come up to 100. And pie chart is something it's a parts of a whole. How many slices is there? Suppose 4 slices, then it's a parts of whole. Suppose here is A%, here is B%, here is C%, and here is D%. So A% plus B% plus C% and plus D% should be 100. Right?
Yes, sir.
Okay, fine. So now we will cover mean and mod and median of categorical data. Mod is something which occur most frequently. Okay. Suppose you have suppose there is a result of rating. Okay, suppose I'm denoted P as poor, A as average, and G as good. Okay, so suppose there is data collected like poor, average, good, poor, then good, average. Okay, so then mod can be calculated. Suppose where you can put it in table. How many categories are there? 3: poor, average, and good. Okay, so you can like tally. You can say suppose P is 1, फिर again age 1, फिर again age 1, then G is 1, then G is 1 time, then P is 1, and G is again, and then A is again, then A is again. Okay, so you have 2, 4, and 3. So mod is the category A. That means average, right?
Yes.
Fine.
Right. Okay.
Yeah, and mod you can interpret from charts. Suppose mod has the widest slice in pie chart, okay, and longest bar in bar chart. Okay, Ishan sir has told about the Pareto chart, right?
Yes.
Yes, I told about.
Okay.
Yeah,
yes, sir.
Finished.
So
Finished.
first, then first bar in ascending order of the, in descending order of the Pareto chart, okay, and last bar in ascending order of the Pareto chart will be the mod. Suppose here widest slice means, suppose this is you have 3 slice. Suppose I have only 2 slices. Okay, suppose this is a 30% and this is a 70%. This is something category A, this is something category B. So this category will be mod. You can easily interpret from the widest slice, and widest slice is this one, right? And longest bar in the bar chart. So suppose I have made a bar chart, and for suppose this one, for this category I made a bar chart. Okay, and you all of you have been aware with the if data is in ordinal, so order must be preserved. Okay, so here data is ordinal, so first we have to put for poor, suppose here is 2, and then for average it is 4, and then it's a good, so it will be 3. So longest bar in the bar chart will be the mod, right?
Yes, sir.
Yes, sir.
And suppose I have make the some ascending order Pareto chart. Suppose here is your category A, and it has 2, and it has B, and it has 4, and some any category has C, and it has count 6. So it's an ascending order of Pareto chart. So mod will be this last bar. Okay, last bar in the ascending order of Pareto chart, right? So last bar will be the mod, and reverse will be the first bar will be in the descending order of the Pareto chart. First bar will be the your mod, right?
Sir.
Okay,
Yes,
so yeah. So and for median, suppose you have data like okay, then first for median, see, median exists only for ordinal data, okay, not for nominal data. Okay, median will exist for ordinal data, because to compute the median you have to arrange the data in order. Suppose here order will be P, P, and again average, G, G, and G, and median is the middle of the observation. So here is total 4, 3, 7 observation, so 3 left, 3, so A will be the median. Okay,
yes,
and suppose you have again G, then these two, any one of these two will be the median, either A or G.
Median, sir, we arrange the data in ordered manner, in ascending or descending.
Yeah, you have to arrange in ascending order.
Oh, yes.
Okay, fine.
Sir, just one question, like when there are even number of terms and we are finding the median for categorical data, like there is different letters like A and G. So we'll write median is A or G, not A and G.
Yeah, either A will be median or G will be median.
Okay, understood, sir.
Got it?
Can we take average of A and G despite of A or G?
What will be this? Can you compute? This actually this is the categorical data, right?
Right.
Okay. So
okay.
So either A or G will be the median. I think week 2 has been covered, right?
Yes, sir.
So there is a missing topic, bimodal and multimodal data.
Okay, see, one second. See here, yeah, here I have explained about mod. Okay, so bimodal is something when two mod of a data exists. Suppose here again your p exists, suppose 4 times. Okay, so data will be your bimodal. Suppose there is another category, suppose there is good, then excellent. Okay, and it occurs 2 times, then data is always then data in that case will be bimodal. And suppose excellent is also occurring 4 times, so you can say data is multimodal. Okay, see, when in your data, if there is only one mod, okay, your data will be unimodal, right? And there is 2 mod, then it will be bimodal. And if there is more than two mod, then it will be multimodal, right? So till this point, I think if you have any doubts, so you can ask. Otherwise, we can move week 3. Okay, so anyone else has doubt, or we should move week 3, right?
So, move week 3.
Okay,
Yes,
fine.
we should move. Yeah.
Okay, fine. So week 3. See, week 3 is basically see, up to week 2, we have studied data, statistics, part of statistics, part of data, types of data, scales of measurements. And in week 2, we have studied about categorical data, relative frequencies for the categorical data, and graphical representation of the categorical data. And in week 3, we will deal with the numerical data. Okay, data has 2 types. Okay, one is categorical, and second one is numerical. Okay, and see, numerical has also 2 types, discrete and continuous. Okay, see, discrete and continuous. What is discrete data? Discrete data is something where you have concept of counting. Okay, and it takes the distinct value on real number line. Suppose you have real line and it takes distinct value. Suppose I'm taking saying number of days to finish a school project. So it can be 1 day, it can be 2 days, it can be 3 days, like this. Okay, and continuous data is something it takes it can take any value within an interval. Okay, and in continuous concept of measurement is involved. Like suppose I'm saying speed of a vehicle. Okay, so if you go for and speed of vehicle can be measured in kilometer per hour, right? So it will be continuous data. And weight of a person will be continuous data. Height of a person can be continuous data, right? And this discrete data, suppose I'm saying number of accidents in a month. Okay, so tell me, any one of you tell me, suppose I'm saying time taken by a person, suppose a student to finish an exam.
Continuous.
Continuous, sir.
Right.
Continuous.
Yeah, it will be continuous, because suppose your exam is up to 3 hours, so it can take any value between 1 hour or 1 to 3 hours, right? Yeah. Okay, let's move ahead. See, in
the case of a single student, it will be only one single number, sir.
Can you repeat?
Yeah, in the case of 1 to 3 hours, one student is writing the examination, then only one value will be getting, sir.
Yeah. Suppose I'm asking about the number of students who are giving the exam. It will be discrete data.
Right, sir. Thank you.
Because you can count 1 student, 2 student, 13 student, 25 students are giving the exam.
Got it, sir.
Got it? Yeah. So in week 3, so we start with the class interval. Suppose this is A and B. Okay. So this is the any class interval, suppose. So this is the lower limit of the class. Okay. And this is the upper limit of the class. Right. And what is the class width? Class width is something, suppose next class is C comma D, suppose, for example. So class width of the something is the difference between the lower limit of this class and difference between the lower limit of this class. Okay. So if you talk about the class width, so A minus C will be the class width. Okay. And I'm talking about, suppose, class mark. So class mark will be, suppose, class mark of this interval. So it will be A plus B by 2. Right? Suppose, for example, you are given the interval like 50, 60, and again 60, 70. Okay. So class width will be 60 minus 50, that is 10. And class mark of this, suppose this interval, it will be 50 plus 60 by 2. Okay. Hello.
Sir, can you explain it once more, sir? Just the class width thing.
Yeah, see, class width is something. Suppose I'm saying, I'm asking about the, tell me class width. Okay. So class width of this. So lower limit of this one, first interval, and difference between lower limit, sorry. Suppose you have interval this and this. Okay. So class width will be lower limit of this category and lower limit of the first one category.
Sir, isn't it B minus A?
No, because see, 60 is excluded, right?
Yes.
Okay.
Okay, sir.
Values are
E
same
minus
actually.
C, na?
See, suppose
you wrote A minus C. It's C minus A.
okay, sorry, it was by mistake. Suppose your interval has like this, okay, and again 70, 80 and 80, 90. Okay. So for this class interval, class width will be 70 minus 60, okay, equal to 10. Right. And suppose I'm asking about the class mark of this interval. So class mark of this interval will be average of these two values. Okay.
Yes, sir.
And class mark will be used for, when your there are category and you have to calculate for mean, and you calculating the midpoint, which is exactly class mark. Like this, suppose here, suppose your category is like this, 70 to 80 and 80 to 90, and your frequency is given for this 2, 3, 5 and 1. Then suppose I'm asking about the calculate the mean of this data. So xi is the nothing but you have to calculate xi, which is the midpoint, which is the class mark. That means average of these two. It will be, which will be, I think 50 plus 60, 100,
55, sir.
Again 65. Okay. Then 75, then 85. So mean will be xi into fi, and your mean you can calculate by this formula.
So we can say this average class mark instead of class mark.
No, actually class mark means you have to take the average of the interval.
Okay.
Okay.
Right. Sir, there is a question in 3.1 where this class mark, the first range is starting from 1 to 20, then 20 to 40, 40 to 60, 60 to 80. So these are not equally, so if we have to take the average, we will take 1 to 20 only, right?
What was the interval? 1 to 20?
The first interval was 1 to 20, then 20 to 40, 40 to 60, 60 to 80, 80 to 100.
Okay, it's a equal interval.
Yeah, week 1 question, AQ 3.1, question number 2.
Okay, whatever it is. See, so suppose I'm asking about the class mark of this one. So you have to calculate the average of these two. That means 20 plus 40 divided.
First one also we will take the average, right? 1 to 20. It will not be 10, right? It will be something.
Actually, suppose any class interval. Suppose you have class interval A comma B. In general, I'm taking, and I'm asking about the calculate the class mark of this interval. Okay, so just calculate the A plus B by 2.
Okay, so in this case, in the first interval, it will be something 10.5. So it's no issue with that, right?
No.
Because it is not starting from 0. It is starting from the class widths are not same.
Okay. You are asking about 1 to 20.
Right.
Okay.
Class widths are not same, sir. That's what I'm asking.
Okay, I think in for best practice, class width should be
same, right? That's what
Yeah.
is my understanding. But in this question, it is, I mean, this is not same.
But if you are asking about the class mark, then you can calculate it.
Okay.
Okay. So, and you can plot histogram for class interval. Suppose you have interval like 0 to 10, okay, 10 to 20, and 20 to 30. I'm taking that for example. So here will be 0 to, suppose here is 10 and 20 and 30. Okay. So 0 to 10, right? And 10 is excluded here, and for the next one 10 is included for this interval. So it will be 10 to 20, and again it will be 20 to 30. Suppose 20 to 30 is it's around 3, it's around 5, and it's around, suppose I'm 4. Okay. So you can plot histogram for the class interval type of data. Okay. It's you can say it's like an continuous rectangle. And in bar chart, your bars are at
Sir,
are
can
not.
you give some example, some questions with regard to the histogram questions?
Can you repeat?
Like can you give some example questions so that we will have the clarity how to apply the histogram fundamentals into the questions, please?
Okay, 1 second. I think there was a question in week 3. Yeah, suppose this data. Okay, this is a histogram. Okay, so and your category is around, see here, 45 to 50. Okay, and 50 to 55, then 55 to 60, 60 to 65. You can say this is a continuous rectangles. Okay, and difference between histogram and bar chart is your bars are there. You can say here is not at a continuous place, it's at a distinct point, right?
Sir, then just one thing, histogram, when we see histogram, then we understand the data is continuous. But for bar graph, it is for discrete data.
Discrete one.
Okay, thank you, sir.
Okay. So next topic is in week 3 as stem and leaf plot.
Sir?
Okay. Yeah.
Sir, 1.5 kg of cabbage is comes under discrete or continuous data?
1.5 kg what of?
Cabbage.
Cabbage. Okay, so actually it will comes under the continuous.
But I can count.
Actually, what do you mean by cabbage?
Is a vegetable.
Okay, you cannot count. You are measuring.
But for measuring, I use for that meter for counting the vegetable.
This is counting banana and cabbage is like you are not counting it, you are taking as a kg. So when it is in that way, it is a discrete. But if you are taking banana with the count, so it will be even if, for example, if you take banana in a kg, so it will be a discrete. If you take a banana as a number of banana or
you are
virgin banana, then it will be discrete.
See. Suppose I am saying shopkeeper has 10 cabbage, then it will be discrete. Okay, because see, suppose I'm saying you are going to a shop and you took the 1.5 kg suppose cabbage and 1 kg potato and suppose 5 gram or you can say half kg tomato, like this. So you are measuring the things in weight. Okay, so it's a continuous.
Okay, sir. Okay.
Right? Yeah. So next comes a stem and leaf. So stem and leaf plot, stem and leaf diagram, it's the best thing. Suppose, and this plot is already you are given in the ascending order type of things. Okay, and for calculating the median, you can easily see, for calculating median, you have to arrange the data in ascending order. But with the help of stem and leaf plot, you no need to arrange in ascending order. You just to count the number of observation and take the middle value or average of the observations to calculate the median. And stem and leaf plot, suppose you can express as, suppose you have two digits like 69, 33, 41. So you can plot it as 33 and 41, 69 and 75. And in general, your key will be provided. I think key is already provided. Suppose I write at 41 means 41.
Yes.
Okay. Okay, that's it. Suppose here is another observation, 76. Okay, so it's a 75, and for 76 you have to write is here 6. Okay, it's a stem and it's a leaf. And suppose I'm saying calculate the median of this data. So you just simply say 69 is the median of the data, right?
Sir,
Because it,
And here also you are ordering now. But you are telling that it doesn't require to order.
I mean, see. I mean to say in stem and leaf plots, it's already in ascending order.
Achha,
Suppose
the moment when we begin with a number like that is like from the smallest one to the largest one.
Yeah. Suppose you let me go with the next page. Suppose data is given like this, 21. Okay, so it's not a right way, because you write 21 first and then 20. Instead of this one, your stem and leaf plot will be like this, 20 and again 21. Suppose your 30 started, then again 30 and 33 and suppose 35. Okay.
So like a Pareto chart, the representation itself is pre-ordered.
Streams always be given in ascending order, no?
Yes, sir, but Pareto chart can be descending order also, but here
Pareto
only
chart, see, Pareto chart can be descending. So Pareto chart is a graphical representation of your data. Okay, and here is, it's also a graphical representation of the data. But here you can easily calculate the median type of things. Mod up. Suppose I'm saying suppose here is 3, 3, and 4. And again say I'm saying 51 or 52, 52. Suppose it's a 53, and I'm asking about what is the mod of data. You can easily see 43 is 210, so 43 is the mod of the data. Okay.
Sir, is it possible to plot 3-digit number or more than 2-digit numbers
on stem and leaf plot? Yeah, it's possible. Suppose I'm write 10. Suppose I have to write 109, so I 10. Stem can be take 10 and leaf will be 9.
Okay, cool.
Okay.
Thank you, sir.
See, and key will be provided. Okay, suppose I can write it as, suppose key is written as like this. 10 given 1 means 101. Okay.
Sir, I have a small doubt, sir.
Suppose
the key is written in the stem, it is only 10, and here it is nothing, it is mentioned here. So it is 10 or 100, sir? Nothing it is mentioned here.
No, that means observations are missing. Suppose I am written as like, suppose this is a stem and this is a leaf. Suppose 2, 1, 2, 3, 3. Suppose 1, 2, and 4 and 53, 54. Okay, so this category is missing. That means 40 to 49 observation are not in this data, right? Because up to 50, from 50 up to 59 can be written in here. Okay.
Yes.
And from 30 to 39 you can write here.
Yeah.
Okay, so here if in leaf any observation is not mentioned, then from you can say I mean whatever is 4, 7, whatever it is, you can say observations are not there. You can't say like it's 40. 40 means
Sir, in case this 4 is the data is not there with 40 digits. So we can skip writing 4, like any number like this.
You can skip. It's on it's depending on you, but for creating confusion sometimes in the question things are given like this.
Suppose digit is key part is skipping, but leaf part is there.
Oh, you are like this.
Like
So,
like after 5, 6 is coming, but here 6 is not there, but 0, 1, 2, 3 is present. Like this picture. Second one.
like this one, okay.
Yeah.
So see, either you can see, first thing, you can write it as like suppose 0, 1.
Yeah, 0, 1.
Okay.
Yes.
So you can take as 1.
Okay.
Okay.
If number is not in a 2-digit, we should make it in a 2-digit. By
Yeah,
okay.
yeah. So, suppose here I'm writing as 5. So it means it's a 0, 5.
Okay. Yeah.
Okay, so next,
So,
I think.
sir, if the stem part is missing, we can assume it to be 0. But if leaf part is missing, we cannot assume it to be 0.
No, you cannot, because suppose I'm writing here 2, okay, and for 20, I must have written here 0.
Okay, so there is a difference between the assumption of stem part and leaf part.
Sir, I have a doubt.
What if I
Related
want
to
to write
the stem.
21.5 in stem
One
leaf?
by one. Yeah.
What if
Okay,
I want
so-
to write 21.5?
21.5, right?
Yes.
Suppose you can write it 1.5 here.
Okay.
Okay.
Thank you.
Thank you.
Okay.
Sir, can you explain this part once more,
This
sir? I could not
question-
understand.
Yeah. See.
Yes, sir. How
Please.
0
Let
is
me
coming.
complete first now.
Yeah, please. Please ask one by one. I think that will be both of us. For yeah. Go ahead.
Okay, so in this question, the stem is missing in the first term. What will be done if the stem is missing between the term, like the first example where leaf is missing? If we exclude 4 and
You are talking about like this. Suppose I'm writing here 1, 2, 3, and suppose I write 3, 4, and again 4. Right, like this. Okay.
Right, sir.
Okay. So see, earlier I said stem and leaf plot are already in ascending order. So you can see it's for 1. That means 10 to 19. Okay, and it can be up to 20 to 29. So it will be 30. You can
Okay,
consider.
okay. So if we exclude 4 and include their 5, then how we will
Here.
conclude there must be 30?
Here 5.
On the stem part,
No.
sir.
You are saying
Stem
about this.
part.
Okay.
Right,
This one.
right. How we conclude
So
there is 3 or 4?
Okay. So I think you cannot say anything.
Can we shift to above 1? This part is.
Sorry.
Can we shift this 0, 5 to above 1?
Above 1 means.
No.
Sir, I want
That is
to upload
incorrect
here.
data.
Yeah, that will be incorrect because
Incorrect data.
Actually, see that in if it's already in on a ascending order 1, 2, 3, 4, then 5, then you can guess, but data are given like this 1, 2, then 5, then 6, so you cannot say it will be 5, it will be 4, it will be 3. Okay.
Right.
And
Okay,
only steam is given then, sir?
Sir, if only steam is
given and no leaf point is given,
then you say see here, suppose 2, 3, 4, and for this 4 here data are not present, so you can say from 40 to 49 observations are not there. Okay. Then you cannot say like there is no observation, then here it will be 40. No, for 40 0 must be there. Okay, so I think let's move ahead for the next mod of numerical data.
So can we treat that 40 as a 4?
No, because 4 can be treated as if we like this.
Okay, I
Actually,
see.
stem plots will be in 20s, 10s, hundreds,
Yeah, yeah.
thousands, like that.
So we will neglect this. We will neglect this 4. Okay, sir.
Okay. See, now we will study mode, median, and mean. These are, measure of, you can say, central tendency. These are called measure of central tendency. Means it gives like, middle observation, you can say an overview of the whole observation. Okay. See, mod is something, mod is, what is mod? Which occur most frequently. Okay. Yeah, which has more count, you can say.
More times.
Okay. And median, median is will be, see, first let me finish with the mod. Suppose you have data like 1, 1, 2, 2, 2, 3, 4. So mod of this data will be 2, right? And suppose you have a mod of any, and suppose I'm increasing in the each observation by adding 1. Okay, so it will be 2, 2, it will be 3, 3, 3, it will be 4, and it will be 5. So your mod is here 3, right? Either, see, suppose this is the it's a short data, so you can easily compute. But suppose you have a long data, long number of observation, so adding adding constant to each observations or multiplying the constant to each observation will be a big task. So that's why there are criteria. If you see, it's the 3, and if you add that constant at the old mod, you will get the new mod, right?
It's same for all 3, right? Mode, median, mean.
Yeah, it's same for all 3, mod, median, and mean. Okay, that means if suppose you have an old data and mod for that data is suppose I'm taking as m1 for old mod. Okay, and I'm adding the constant to each observation, and suppose you have observations x2, x1, x2 up to xn. Okay, and I am adding the constant to each observation. So your new mod will be this old mod plus this constant. Hope this is clear to you, right?
Yes,
सर अगर एक ही
Yes, sir.
ऑब्जर्वेशन
Yes, sir.
कांस्टेंट ऐड करें तो
Sorry,
एक ही ऑब्जर्वेशन में कांस्टेंट ऐड करें तो
so that will be, you can write, suppose I am adding in only one observation. Okay, suppose I am adding in 1. Okay, so it will be 2, 1, 2, 2, 2, 3, 4. So your mod is again 2. Right?
okay.
So I don't think there is, there will be case like it can happen. You can add 1. Okay, so similarly for median.
Sir, in case of mod, if there is a tie, like there are two numbers that have same number of
Yeah,
observations.
it happened. Then data will be bimodal.
Okay, so both of them are basically mod.
Yeah, both of them will be mod. Okay, for median, suppose I'm taking the previous data 1, 1, 2, 2, 2, and 3, 4. Okay, 1, 1, 2, 2, 2, 3, 4. So it's 7. Okay, 7 in numbers, and it's already in ascending order. So your median will be middle observation in if your number of observation is odd. Okay, so your median is 2, right? And similarly, suppose I want to add a constant to each observation. Okay, so suppose I want to add 5 to each observation. So it will be 6. See, new data will be 6, 6, and 7, again 7, and again 7. It will be 8, it will be 9. So your median of the new data set is 7, right? Okay, so here similar as I told in the case of mod, suppose your number of observation is large, so in that case it will be big task. So in that case you can directly add that constant to the median of the old data, and you will get the same median if you calculate the manually. And similarly for if you are multiplying by any constant to each observation, your new median will be multiplied by that constant. Till this point is clear?
Yes, sir.
Okay. So it's
the
new
condition
mode.
is same for both mode as well as for median.
Yeah. Suppose
You're
I'm
just
adding
that
some
new
constant, and a new mode will be, suppose I'm adding multiplied by some constant. So your old mode will be multiplied by this. Okay. Similarly, your suppose new median will be old
Sir,
median. Yeah.
If we get two modes like bimodal, we need to add the constant for two modes.
Then both mode will be your change. Okay.
So you mean to say like either I add a constant or multiply a constant, the new mode will be old mode for plus the new constant one, right?
Yeah. Actually, suppose you have 25 observations. Okay. For example, you had 25 observation, and a median of that 25 observations, suppose it's coming out to be 15. Okay. And I'm again saying, suppose this is a marks of 25 students. Marks of 25 students are given, and median of that data is 15. For example, listen to me carefully. And suppose I want to increase the marks of each student by 2 marks by adding 2. Okay. So it will be big task for anyone. No, you have to add each of the 25 marks by 2. Then you arrange in ascending order, then calculate the median. Instead of there, if you know the formula, then new median will be old median plus that 2. That means new median will be 17. Right? Hello.
Yes, sir.
Yeah. Okay, fine.
Yes,
so
sir.
till this
Yes,
point, I hope you have no doubt. Okay.
Sir, is it possible to explain question number 4th and 5th from practice assignment 2.2? That's a Jersey question.
2.2. Actually,
Yes,
I
sir.
think let's finish first of syllabus.
Okay, sure, sir.
Because we have half of third week is half remaining, and whole 4 week are remaining.
Okay, sure, sir, sure.
After that we will discuss. Okay. No worries.
Sir, in case of even number of observation, it will be an average of.
Yeah. In case of even number of observation, your median will be. Yeah, who is this? Please mute yourself. Live चल रहा है तो बंद करो भाई. Yeah, actually, so suppose your number of observation is even. Okay. So your median will be mean of the n by 2th observation and n by 2 plus 1th observation.
And this thing is different from categorical.
Yeah.
Right?
Actually, for numerical data, you can calculate mean.
Okay.
So
yeah, but the same thing we are not doing in case of mode. The taking of average.
No. Why mod is something you have to just count, which occur more frequently. That will be the mod. There is no need of taking the average of things.
Okay.
Next, move ahead for the mean. Okay, mean. Yeah.
Hello.
Yeah.
Sir, if there are no repeating data for mod, what we will do?
Actually, mod in that case, you can say mod is undefined, because mod is something which occur more frequently, right? So mean is your summation xi by n, or another formula is mean. Suppose your frequency is given, then it will be summation fi into xi divided by summation of fi. Okay. And similarly, see, suppose your observation is x1 to up to xn. Okay. So mean, and I'm adding a constant to each observation. Right? So what will be the new mean? If you see, so new mean will be your summation of these divided by n observations. So summation of these will be x1 plus c, it will be x2 plus c, and so on. It will be xn plus c divided by n, right? If you see, c is added up to n times, so it will be x1 plus x2 plus so on. It will be xn plus n times of C divided by n, right? Hello.
Yes.
Yeah,
Yes,
it's
Yes,
clear.
sir.
Yeah,
Yes,
yeah.
Yes, sir. It's okay.
So next step will be your x1 plus so on xn divided by n plus n C divided by n will be cancelled out. So what is this? This is the old mean. That is nothing but it's a summation xi by n plus C, and your new mean is this one. So your new mean will be this x bar old, that means old mean plus C. So this x bar new will be your old mean plus constant. Okay. Similarly, it will be for multiplying. Suppose I'm multiplying by the constant. Suppose your x bar will be C xi divided by n. Okay. I'm multiplying by C to each observation. That will be C come out to be outside of this equation. So you can write it C into x bar old, and this is your so x bar new will be C into x bar old. Okay, so equations are same for both cases, you know. Sorry, both, I mean mod, for median and for mean also, constant will be added to new mean, new median, new mod, and constant will multiply to new mean, new median, and new mod, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
I have a question in mode.
Sorry.
I have a question with the mode.
Yeah, go ahead, please.
You can, if we have a data set like 1, 2, 3, 4,
then
there is no mode, or we have 4 modes because
no. Suppose you are saying 1, 2, 3, 4, right?
4, yeah.
But you don't know which occur more frequently.
Yeah, everything has frequency 1.
No. Then mode will be undefined.
Undefined. Okay.
Okay. So see, suppose why we use median and mean like this. Suppose you have observation like 12 and 18, then it will be 13, then 10. It will be 40, and suppose again 10, and suppose I am taking as 205. Okay. If you no worry. So just take it as 20 firstly. So what will be the mean of this data? It will be 20, 30, 40, and it will be 70 by 5, 14. Okay.
Yes, sir.
And what will be the median of this data? Your the median will be, I think, 10, 10. If you arrange in ascending order, 12, 18, 20. So your median will be 12, right? And suppose instead of this 20, I'm taking as 205. Okay. So if you arrange this data, it will be 12, 18, 205. So your median is same. Median is not changed. But if you calculate the average of this data, I mean 12 plus 18 plus 10 plus 10 plus 205 by 5, it will be 20, 30, 50, 255 by 5. So your answer will be 51, right? So if you see, there is a lot of change in mean. Okay. So when in the data you have extreme values, that means if you see by the extreme values, median is least affected. You can say median is not affected, but mean is affected.
Outlier.
Yeah. The extreme values means, I mean, extreme values are outliers. Okay.
Yeah.
So in case of extreme values, median is more preferable. Because if you see mean is, suppose for previous data, your mean is 14. Okay, which is you can say for this data is around for this center, which is a good. Again, median is 12, which is also good. But if you see this data, your mean is changing a lot. Okay, there is effect of these extreme values, but your median is not affected, or you can say it will be least affected, right? Okay,
Yes, sir.
Means due to outlier, only mean will affected.
Median can be affected, but it will be least affected. For suppose there are a lot of number of outliers is more, then median can be affected, but it will be median is least affected.
Yeah.
Okay.
Thank you, sir.
So measure of central tendency is clear. Now we will move ahead. Measure of dispersion.
Yes, sir.
That means measure of dispersion is you can say there is range. You can calculate range by maximum minus minimum. Okay. Variance. Next one is standard deviation. Okay. See, what is range? If you see, range is also affected by the outliers. For the previous data was 12, 18, 10, 10, and 20. Okay. So range can be for this data. Maximum is 20, minimum is 10. So range will be 10. 20 minus 10, it will be 10. Right. And suppose I'm writing 205, for example. So your range will be 205 minus 10. It will be, I think, 195. So you see range is also change. Okay. So you can say there is effect of outliers for range. Okay.
Yeah.
Fine.
Yes, sir.
Yeah. See, and now we will come on the variance. What is variance? Actually, variance is see, what is the mean? Mean tell you the central tendency. Suppose you have two data. I'm saying suppose 1, 2, 3, 4, 5, and suppose I'm taking 3, 3, 3, 3.
So sorry to interrupt you.
Yeah.
There's one question. So you are actually talking about the extreme part of the element is getting changed, right? So you're only altering the values of the numbers. You're not actually adding a new elements there.
Okay, suppose here I'm adding, suppose 20 is there. Suppose 20 is there. Okay.
Yeah, you're adding additional. Yeah.
Okay, suppose 205 is there. Then what will be the range? Range again will be 195.
But in this case, actually, the median will also change, right? If I'm adding additional elements.
Yeah, suppose median is changed. What will the median? Median will be your, once let me arrange 10, 10, 12, 18, 20, and 205. Okay. So there is 6 observation. Median will be your 12 plus 18 by 2. It will be 15. Right?
But earlier case, it was only one, right?
Earlier it was only one means? Yeah, actually see here, you have even number of observation, right?
Correct.
Hello.
Yeah, I understood. But what I'm asking is, earlier you were saying that the median will not be changed. Only the mean will be the major impact.
No. See, I said median is not changed for that data, or median can be least affected by the outliers. Here, median is least affected by the outliers. Suppose.
Okay, so it will be affected based on the change. It's not.
Suppose you are you calculate the mean for this data. Mean will be changed a lot, right?
Yes, mean is changing a lot.
Suppose mean is, if I can remember, mean was earlier data was 14, and for if adding outliers it will be 51. Okay, mean is changing a lot, and your median is changing 12 to 15. So which one will be most preferable? Median.
Correct.
Right. So
I was in the impression that it won't change actually. So
no,
slightly changing. So it is acceptable.
Yeah. See, I said median. Median is not affected. You can say, or median is least affected. So it's depend on the what is your data.
Understood.
Yeah. So concept of variance come when suppose you have two data, and mean of this data will be 3, and mean of this data will be 3. Mean is same, but suppose I'm asking about how much vary the observations from the mean. Okay. See, suppose here, if you see there is a variation from the mean is, you can say like 0, because 3 minus 3, 3 minus 3, 3 minus 3 will be 0. There is no variation. But for this data, there is variation. Minus 2, minus 1.
You are asking range.
Sorry?
Essentially, you are asking for range. in both these data?
No. A range has been covered, right?
Yes, range finished.
Range finished. I'm saying, suppose when variance came. Suppose you had two different data. Okay, one data is 1, 2, 3, 4, 5, and again was next data is 3, 3, 3, 3, 3. Mean of the first data is 3.
Okay.
Second mean of the
Yes,
second
correct.
data is 3, right? But if suppose I'm asking how much variation is there from the mean, if you see for the second data, there is no variation from the mean.
Yes, sir.
Oh, I see.
But first data, there is variation.
Yes.
Yeah, correct.
Okay, that's why the concept of variance is come, means how your data is varying from the mean with respect to mean.
So we have to subtract mean from every indices of this data.
Yeah. Actually, that's actually if you see
Xi minus X bar.
Yeah, what is the formula of variance? Variance formula is 1 by n. I'm taking as population
Xi
variance.
minus X bar.
Xi minus X bar whole square.
Yes,
Right?
sir. Yes, sir. Yes,
It's
sir.
a formula of population variance. Okay.
Yes.
For sample variance, it's 1 by n, nothing but.
Minus n.
And one
Yes.
things remember, I think in the last session anyone has asked, he was confusing. He was thinking like here is n minus 1, so here it will be n minus 1 also. No, summation will be for all the n observations. Okay.
Yes, sir.
This will be we have to add up
Okay,
all the observation, but for the sample variance, your denominator will be n minus 1. For population variance, it's n. Why it's n minus 1? It's out of syllabus, and you will study this type of things in stats too. Don't worry about that. Just remember the formula, like population variance formula is this, and sample variance formula will be this. Okay.
So variance and covariance are different, na? Or
Yeah,
same?
different. Because see, variance is for one variable. Okay. And covariance for two variables. And I will discuss in week 4. Okay. Let me finish it. Just remind me these things. Okay. I will discuss. If you see, variance is will not change if you add the constant. For example, your previous data is x1 to xn. Okay. And I'm adding the constant to each observation. Right? The new variance will be 1 upon n summation I to n. Suppose xi plus c it will be. Right?
Yeah.
And from the previous one, mean will be added also.
Plus c. Yes, sir.
Okay. So 1 upon n summation I to n xi plus c minus x bar minus c whole square. C will be cancelled out. So it will be same as your old variance.
Yeah, new variance is equal to old variance.
Okay. That means adding constant to the observations, your variance will not be changed.
Yes.
Right?
Sure.
And suppose I'm multiplying by the constant. Let me go with the next page. Suppose what is multiplication? It will be c. No.
Yeah.
C times of
xi
minus c times of x bar whole square.
Yeah.
Right. So your c will be outside of this one. Okay.
Yes,
if you take this c outside, then it will be c square.
Yes, sir.
Okay. So if you can write it as 1 by n summation xi minus x bar square. So c square into old variance. Your new variance will be c square is equal to old variance. That means, see, if you add by constant, so variance will not be changed. If you multiply by any constant, so new variance will be square of that constant into old variance. Right?
Sir, if we will divide, then?
See, if you divide, suppose I'm saying suppose you are saying I'm divide by 10. Okay. That means you are multiplying by 1 by 10.
1 by 100.
So it will be 1 by 100.
Yeah. Okay.
Right?
Yes.
So I think till this point.
Sir, addition वाला आपने क्या बताया? Like if you are adding the constant, it will not change the variance.
Yeah. Variance will not be changed because see, if you see in data, I'm adding the constant. Similarly, for mean, constant will be add. Okay. So if you minus will go inside the bracket. So this C is in the plus sign and this is C in the minus sign. So this both C will be cancelled out and it will be came at the old variance. That means your variance will not be changed. Right?
When people subtract, then also will not be changed.
Also will not be changed because you are subtracting.
Yeah.
Suppose this is the minus. This is the minus. This will be minus and this will be plus. Again, it will be cancelled out.
Yes. Got it.
Got it?
Yes, sir.
So now next move for the standard deviation.
One last वाला जो आपने बताया था, like when we're this main mode आपने बताया था ना, like main mode, but actually उसमें what about the this thing? Like, sorry, I got confused. Median actually it is not changing if you are adding with a outlier. It's a huge number of outlier. The median does not get affected, but the mean get affected, right?
Yeah. That is the case for extreme values, for outliers actually.
Okay, so what about mode? Median does not change, but mean gets changed.
Actually, mod, see, according to data, what is your data? Mod is in general, mod is also least affected by the outliers. It's depend on the data actually. Okay.
So we cannot predict if any outliers are there. Like so, whenever we are inferencing or any analysis, we are doing descriptive analysis. If in the data set outliers are present, so most preferable is the median one we should consider, not mean or not mode, right? So if the mode is getting affected, I agree because you are saying that it depends upon the data. So then we need to focus on the two things, then mode and median, right?
Can you repeat your last statement?
Let us say I have a data set and I need to do some analysis and inference from the data set. Okay. And I know that in my data set there is outlier present. Okay. So because of the fundamental what you gave, so I cannot consider mean because it is getting affected because of the presence of the outlier.
Yes.
My focus should be considering median or mode.
According to your purpose, you want, say, suppose you want most number of occurrences, so you will go with the mode, and for central density, you can consider the median.
Okay. So after that you started this variance, no? Because
this variance part, and now standard deviation. Standard deviation, yeah.
How will you identify population variance or sample variance? Which formula where we have to use?
See.
Given that.
Yeah, this formula 1/n summation xi minus x bar square is used for the calculating the population variance, and for sample variance instead of n it will be n minus 1.
Where we have to use that formula, sir, in this given data?
No. Actually, in the question, listen to me. In the question, there will be mentioned you have to calculate sample variance, you have to calculate population variance. No worry about that. Okay, it will be clearly mentioned in the questions. Yeah.
Thank you.
So one simple doubt actually before you proceed. So we actually started with a central tendency of the median and mean. So after that you came to ranges and then finally you were coming to variance. So in real time, what is the actual use of this variance? I can't actually correlate what is the use of this central tendency. I can understand, but what is the use
actually,
of this variance?
see variance I explained. Actually, see, suppose you have two data set, okay, and mean of this data set is 3. Also, mean of this second data set is 3. Okay, means are same.
I got the calculation, sir. I got actually the calculation and everything. So you're coming to a final stage of applying the formula.
How your
Actually,
data is
varying.
How your data is varying.
How variability is there in your data corresponding to your mean. Okay. In that case, you have to
for each element.
Yeah, for each element.
Across each element.
That's why in your
You will
formula,
get the average data. From the average data, you will tell how your data is varying in respect to the average data. How much you have.
That's why your each observation is subtracted from the mean.
Yeah, I understood now. I understood. And same thing for the standard deviation also.
Yeah. Actually, see, invariance, standard deviation came into when, see, invariance, suppose your data is of, weights of some, your data is collected of weights of 10 persons. Okay. So your variance came out to be in kilogram square. Right? Okay, because the formula of this one, your variance will come in the kilogram square, but your original data was in kilogram, your variance was in kilogram square. So to compare from the, to maintain the units as same, standard deviation came into effect. That means if you took the square root of this one, your data will be in kilogram unit. Okay, that's why standard deviation came, and it took as the it's nothing but is the square root of the variance, because the square root of something, suppose x, square root of the x square is x. Okay, so there is formula of population standard deviation, that will be 1 upon n summation xi minus x bar square. Okay. And sample standard deviation will be your 1 upon n minus 1 summation xi minus x bar square. Right?
Yes.
Yeah. And you see there is no change on adding the constants on variance. Okay. So similarly for standard deviation, if you see here, if I took the only square root of this one, okay, so your standard deviation will also not change for adding the constant, right?
Yes, sir.
Till this point is clear? Yeah.
Yes.
And suppose for I'm multiplying by the constants, so suppose your this one, your new variance was c squared times is 1 upon n summation xi minus x bar square. Okay, so your new standard deviation will be square root of this whole things. Right? So your c will be outside, though it will be c, and it will be 1 upon n summation xi minus x bar square, which is c into old standard deviation. Right? It's clear?
Okay.
Fine.
This is for the multiplication.
Sir, this is for the multiplication, right?
Yeah. This see. If you add the constant, your new variance will be old variance. If you multiplied by any constant, your new variance will be c square. That means that constant is square times old variance. Okay. And if you similarly for standard deviation, your new standard deviation will be same as the old standard deviation if you add constant. Okay. And for new standard deviation will be c times of old standard deviation if you multiplied by any constant. Right?
Sir, there was a question in mock test 4. It was similar kind of new variance and old variance, right? But the answer was not correct when I did with the c square.
I think there will be some. There can happen some.
Sir, the question was like the multiplying each of the number by 4 and then adding 7. Because if adding 7 doesn't make any difference, then multiplying by 4. Multiplying by 4 means it should increase by 4 to the 4 square, right? That is 16 minus the original one.
16 into original one.
Okay. That's where I made mistake. Okay, I just 16 into, then we will have to subtract the original one. But what will be the difference? Then difference would be only 15, na? 16 into old minus old should be 15.
Old should be 15 means?
No. Suppose the new variance is 15 into old, and the old variance, say old variance of, say it was x, right? So 16x minus x would be the delta between the variance, right?
Why are you subtracting x actually?
The question was like that. The question was asking.
What is the question?
The question is by multiplying each of the numbers 4, 5, 7, 11, and 13 by 4 and then adding 7 to each of the term, we obtain a new data set. Then the difference between the sample variance of the new data set and sample variance of the old data set is.
Okay. You are asking about the difference. Okay.
Right, sir.
Yeah. Your new variance will be 16 into old variance. Okay. And you are asking about the difference, then this minus this. Oh, sorry.
But sir, answer was not correct,
minus,
sir.
Old variance.
But answer was not correct, sir.
Okay, see,
you can.
I will check, and in last we can discuss it with calculation.
Okay.
It's multiplying by 4. It's multiplying by 4 and add by 7 in the question.
Right. Yeah.
Okay.
It is the second question in the mock test. I think everybody will have received that mock test.
Okay, so your next topic is percentile, right? See, percentile is something, suppose I'm saying, 20%, 25%. Okay, so that means is your 25% of data will lie, will be less than or equal to this point. Okay. And suppose I'm telling 50% of the data, that means 50% of the data will be less than or equal to till this point. Okay, that is some meaning of the something percentile. And see, and to calculate manually the percentile, you have to calculate first of NP, where n is your number of observation, p is something which percentile you have asked, and suppose your NP is in integer. Okay, value of n into p will suppose in integer, so you have to take the average of NP and NP plus 1. Okay, and if your NP is in decimal, came out to be in decimal, then you have to took the next highest integer of the data. For example, your n is 10 and I'm saying p is 0.25. Okay, so your NP will be 2.5, right? So your third observation of the data will be your 25 percentile. Okay, and before that you have to arrange your data. After that you have to calculate this one.
Sir, here n is a number of observation, right?
Okay, sir. Okay. And suppose I'm saying n is 10 and p is 0.30. Okay, so your NP will be 3. So that means your 30th percentile will be average of third and fourth observation of the data. Okay. Okay, so next move with the quartiles.
Sir, then third and fourth observation, then we need to do average, or only we should do?
No, you have to take the average. I said third plus fourth observation divided by 2.
Acha.
Okay, if your NP is come out to be in integer, then you have to take the average. Otherwise, if it's in a decimal, then you have to consider the next highest integer.
Okay, thank you, sir.
Right. Next one is something quartile. Quartile is something, suppose denoted as Q1, Q3, and Q2. So these are the quartiles which divides your data in 4 equal parts: Q1, Q2, and Q3, where Q1 is 25% of data, Q2 your 50%, and Q3 is your 75%. If you see, this is 25%, this is 25%, this is 25%, this one is 25%. Okay, that's the something quartile data. Quartile. Okay, and to calculate Q1, you can easily calculate Q1. You can calculate NP. N is your number of observation. N is the and P is your 0.25. You can calculate Q3 and into 0.75, and Q2 is a 50%, which is nothing but the median of the data. And you know what is the median? Median is which equally divides your data, right? And I think there is something 5-number summary, and 5-number summary includes your minimum value of the data, Q1, and Q2, again Q3, and then maximum of the data, right? These are the called 5-number summary. Okay.
Yes, sir.
And there is another concept is IQR, which is known as interquartile range. Okay, interquartile range, which is calculated as Q3 minus Q1, right? And there is also another thing, outliers. So outliers can be calculated as, outliers should be less than 1 Q1 minus 1.5 times of IQR, and outliers can be greater than of this value. Okay, so I think till this point, anyone have any doubts? I think week syllabus of week 3 is...
Sorry, the IQR is nothing but a Q2?
No. It's a difference of Q3 and Q1.
Okay.
And it's see, 5-number summary you can plot with the box plot. Actually, it's a maximum of the data. It's represent Q3. It's represent Q1. And according your data, your Q2 can be here also, and your minimum of data is there. Okay, box plot is a good representative of the 5-number summary.
Sir, can you repeat that one? That you told na NP Q1, Q2 is NP 0.5 and Q3 is N into 0.5. The last one.
This
so
one?
Here, yeah, that much only we need to, if outliers we need to calculate here, we just go by Q1 N into 0.25, N into 0.5.
See, for outlier is the observation which is less than this one, this quantity. Okay, so you need to calculate Q1 and IQR, then calculate this quantity. If suppose this quantity is coming out to be minus 70, for example, suppose, and you will search if any observation which is less than minus 70, that will be the outlier in your data. And suppose you calculate this quantity and this quantity coming out to be 190, and you will search in your data any observation which are greater than 190 will be the outlier, and any observation which are less than the minus 70 will be the outlier. Got it?
No. Yes, sir. This one I understood, but the previous one which we are explaining now, Q1 is equal to 0.25 N, 0.5 N, and 0.75 N. Just go.
One second. Yeah.
This one. Actually, sir, here what exactly you're trying to say? Okay, if I calculate Q1 means I will do 0.5 into N, a number of observation, and Q3 means 0.75 N, and Q2 means 0.5 N. That much only, na?
Okay, and this will come out to be, suppose I'm taking as 10, and is 10, it will be 2.5. That means your third observation will be Q1. Suppose third observation is 15, for example, whatever data, and your, if n is 10, so it will be 7.5. So next highest integer will be 8, and suppose eighth observation is 35. Okay, so your IQR will be 35 minus 15, neither 8 minus 3.
Achha. Okay. I got it. Okay. Thank you, sir.
Thank
you. Can you please explain percentiles once, sir?
Yeah. See, suppose percentile is something. Suppose I'm saying 100 p percentile. That means let it be. I'm going with the example. Suppose I'm saying 25 percentile. That means 20 less than or equal to. That means this up to 25% of the data will be less than or equal to this point. Okay, suppose I'm saying 70th percentile. That means 70% of the data will be less than or equal to this point, and 30% of the data will be greater than this. Right?
And nowadays,
Nowadays, when we have marks in percentiles, right, in some of the exams, so does that, so suppose someone scored 60 percentile, so does that mean that 60% of scores or 60% of students have scored less than
less than you?
Okay.
Okay, suppose you scored 60th percentile. Suppose you scored 67 marks. Okay, which is 68th percentile of the data. That means the students who are participating in the exam are that means 60% are students are less than you in the in comparison of marks. Okay.
Thank you.
Thank you.
One question.
One second. One by one.
Yes. So the percentile 25 and Q1 is not same, right?
Actually, I did not get. Can you repeat?
So the percentile 25 and Q1 is not same, right?
No, it's the same because Q1 is the 25th percentile of the data.
So I can take the Q1 is actually 25 percentile and the Q2 is 50 percentile.
Q1 is 25th percentile, Q2 is 50th percentile, which is as same as the median, and Q3 is 75th percentile of the data.
It's only the name which is been assigned here in the form of
actually, what is quarters? Quarter is something 1/4. Oh no, I think it's
got it.
1/3.
1/4.
Okay.
Sorry,
so I can use the same formula here. So I can use the same formula for Q1, Q2, Q3.
Yeah, you can use as a n by 4th observation is a Q1.
Okay.
Okay.
Yep. Thank you.
And 3n by 4th observation will be Q3. Got it?
That is what we are doing now. 75% is 3 by 4. 25% is 1 by 4.
1 by 4. That's
50% is 1 by 2.
Okay, so I think we can.
One question here, sir. Suppose 5% have a same percentile. As per your statement, you are saying if I have a 68 percentile, everyone is below that. If 4 or 5 have the same percentile, then how can we say like that?
See, if then in that case,
equal to, sir, so it will come in equal to, less than or equal to.
Yeah. But in that case, you can say, see, suppose you got 67 marks. Okay. Another one got 67, another one again got 61, 61, 67. Okay.
Yes.
So each of them, suppose you can say also, 60% or students are below of my marks. This can also say, this can also say, this can also say.
Can also say.
Okay. Because it's same. Okay.
Okay.
So we can discuss few minutes for doubts of up to week 3 if you have either this one, or we can proceed with week 4 accordingly. You
proceed tell to week 4.
Week 4, sir.
Proceed to week 4, sir, please.
Proceed. Okay,
it's
fine.
More than 3 hours.
Okay.
Maybe you are also exhausted.
Actually, initially 40 to 45 minutes our wasted in connecting network.
True.
That's actually
true.
Yes, sir. Yeah, sorry about that. Actually, I was trying a lot, and I got.
Not an issue, sir.
Okay. So we will move for the week 4. Okay.
Prashant, if I think it's too late for now, if possible, can we move week 4 to the next session on Thursday? Many students have left.
It's
next session will be on mock test doubts, right? It will be
yes, sir.
Again.
For first 30 minutes we can cover week 4 and then go for mock test if possible.
It's possible, or for 10 to 15 minutes. Listen to me.
If you are comfortable, please finish week 4. If you are comfortable to teach, then you teach for week 4. Then whoever have doubts, they will be there. Others will leave.
Okay. I think I can do. Isan, I think it will be fine. 10 to 15 minute a quick revision because crowd is not there also. And in the next session, you can continue with the week 4, right?
Based on your comfort levels.
Yeah, I was saying just many people have left already.
Yeah,
It's
yeah.
okay. You should not
Actually,
do
this is revision session for everyone, and it's too late. That's why I think it will
Those
be
who
okay.
are interested, they will stay. Those who
Yeah,
want to
Actually,
learn.
see, listen to me. I will do a quick revision. Not go with the all the calculation type of things. And in the next session, I think it's on Thursday. And the first 30 minutes, 40 minutes, week 4 will be discussed, right?
Yes, sir.
Okay. So I'm
Yes, sir.
doing
Go
the,
for it, sir.
I'll do a quick revision. Okay. Thank you, sir. Yeah. So
Sir, I have a doubt, sir.
From which?
Sir, why we are considering that outliers that is less than Q1 minus 1.5 into IQR?
It's
So
a
why?
it's a type of, you can say it's a formula type of things. Okay.
It's like to know what are the black sheeps in our data. What is the irrelevant data like?
Yeah. Okay. See, this is something. This is something we consider as Q3 plus this quantity in box plot, and this is something you can consider is this quantity, right? Oh no, sorry. This maximum can be considered as this quantity, and this minimum can be considered as this quantity, right? And below this one, outlier will be there, and greater than this one, outlier will be there. Okay.
Yes, sir. Got it.
Okay. So let's move at I think more 10 to 15 minutes. Okay. So contingency table. Okay. Contingency table. Suppose there is observation of something yes, no, and here is female and male. I'm taking the example of video lecture, and suppose there is A, B, C,
Sir,
D.
can you share your screen, please? And on the screen, could you please show that one?
Sorry?
On your, could you please share your screen and share the things which you are telling?
Okay. No worry. I think no, it's will be in this one.
4.2 सर एक्टिविटी नीचे वाला 4. उसके ऊपर वाला
relative frequency. Yeah. See this one. Okay. See your 1 second. Yeah. Suppose your data is like this. Okay. And you can calculate the row total. Okay. And you can calculate the column total. See, to know the association between two categorical variables, we have to calculate either row relative frequencies or column relative frequencies. And if each, so suppose you can calculate row relative frequency as 10 by 44, 34 by 44, 14 by 56, 42 by 56. Okay. Similarly, 24 by 100 and 76 by 100. If if each row relative frequencies are same or approximately same, you can say, or closer to each one, then variables are not associated. If it's vary, then it's not same, then variable will be associated. Okay. So for example, here you can say I think there was an example of this one. Okay. See, if you compare this one, 41.6%, 44.74%, it's approximately closer to 44. Okay. It's a 58.33, 55 point. It's approximately closer to 56. So here you can say variables are not associated. Okay. If its difference is significant, then you will say that variables are associated. Okay. This is for association of the two categorical variables.
Yeah,
okay?
Actually, sir, sorry to interrupt, but what does that mean when we say that the variables are associated and not associated?
Means,
what exactly it means? Yeah.
Exact meaning is that there is any association between a gender and owning phone.
Association means here relation.
Relation. Suppose is there? Can you see? Is there any relation? Female cannot own a phone, or female can own more phone. So to know to know the association between two categorical variables, we have to do the go with the contingency table, right?
Got it.
It's
Got it.
just
Thank
like
you.
coordinate plane, how our y changes with x.
Yeah, yeah, yeah.
So
This
it's
is
like one-to-one function, maybe.
Yeah, see, next one is I'm going with this is the stacked bar chart. Stacked bar chart is something, suppose I'm explaining each category. Okay, suppose 20%, suppose I think yeah, suppose here you can say red part is showing the yes and blue part is showing no. Again, for male category, red part is showing yes and blue part is showing no. So for the for the example, suppose it's 40% of female owning a phone and 20% of female not owning a phone. Again, you can say I think it's around 15, not exactly 20. And here you can say yeah, 60% of male owning a phone and 18% of the male not owning a phone. So stacked bar chart is something when you are not type of interested in a count, you are interested in whole category. Yeah, S is there and no is there, S is there and no is there. Okay.
Okay, thank you.
Okay, and suppose bar is something, suppose bar is I draw the bar. I simple draw the bar. I say, yeah, there are in total 44 female and there are 54 male in total, right? Okay.
Yes,
This point is clear, right?
Yeah, yeah, quite clear. Thank you, sir.
Okay, so yeah, next concept is your covariance, and then correlation, and then we will discuss the point biserial. Okay, we will do a quick.
Sir, just
quick
sorry
and-
to interrupt. So you were telling that you will tell the difference between that covariance and variance thing while explaining
Okay.
that.
Okay. See, covariance is something. It's it quantifies to you the strength of the linear association between two numerical variables. Okay, covariance of the, suppose I'm saying covariance of a x y is 0. That means there is no association between the x and y. And you know the covariance formula, 1 upon n summation xi minus x bar into yi minus y bar, right? And it's a population covariance formula, and for sample one it will be n minus 1. Okay, so if suppose I'm saying covariance between x comma x, for example, it will be 1 upon n minus 1 summation xi minus x bar. You see here was y, then it was y. Okay, here is your again x, so it will be xi minus x bar, right? So you can write it as 1 minus n minus 1 summation xi minus x bar square. It's nothing but variance of x. Okay, so covariance is computed between two different variables, and for single variable you can calculate the variance, which is same as this one. Clear?
Sir, just can you repeat the last line what you said once more, sir?
See, covariance is calculated between two variables. Okay, and
Okay,
variance will be for one variable, because if you see, if you calculate the covariance for the same variable, it's nothing but the same as the variance.
Yes, sir.
It's the formula of variance, right?
Yes, sir.
So that's why.
Okay.
Okay.
Thank you, sir.
Thank you.
How covariance is affected by that addition and multiplication? Is it affected by constant addition?
Yeah,
and
yeah,
multiplication?
it can be affected. If you see, that's why I want to go with, see, xi plus c will be here, minus x bar minus c will be there. Okay, y plus c will be there, minus y bar minus c will be there, right? Your constant will be cancel out, so it will not be affected by the addition of things, right? If you multiply it by the constants, so suppose here it will be c times let me go with the next one. It will be the c times of xi minus c times of x bar. Okay, and it will be c times of yi minus c times of y bar. Then it will be 1 upon n minus 1. So here your c will be come out to be outside, and again your c will be came out to be outside. I think I'm doing right. Yeah, and correct me if I'm doing anything wrong. I think, yeah, c square will be came out to outside this one. Okay, So multiplication of constant will be there. Okay, got it?
Yes, sir.
Okay.
Sir, one more thing. So, as you said that variance is for only for one variable, and covariance is for calculation strength of linear relation between two numerical variables. So, variance say for one variable. So, can you give an example? Like one example I got for the two numerical variables, that women or men, whether they like phone, this let us say Nokia phone or not. So that is like covariance we are calculating between the two numerical variables, right? But here one variable, one variance, for variance for one variable, can you give an example, please?
Okay, suppose I'm giving to age of students. Okay, and it was 23, 40, no, taking as 29, 30, 21. Suppose I'm saying they calculate the sample variance of data. So it's a single data, it's a single variable. You can calculate the sample variance by this formula. And suppose that I'm saying there is age of male student and age of female student. Okay, and you have to calculate the covariance between these x and y. So just calculate the I'm saying suppose sample covariance. So it will be this. It will be xi minus x bar and it will be y minus y bar. Got it? So there two variables will be clearly mentioned.
Okay. Got it.
And okay. So and next one is topic your correlation. Correlation is denoted at R, and which is nothing but covariance of xy divided by standard deviation of x into standard deviation of y. It's a sample standard deviation, it's a sample standard deviation of y. And just remember, if you use the sample standard deviation, then you have to use the sample covariance, right?
Yes, sir.
And if you are using the population standard deviation, suppose I am saying just calculate the correlation, okay, then you can use population covariance formula and population standard deviation formula. But just remember things, if you use the population standard deviation, then you have to use the population covariance. That's why R will be come out to be like this: summation xi minus x bar, yi minus y bar, divided by square root of summation xi minus x bar square and square root of yi minus y bar square, right?
Yes,
because if you use suppose population, it will be 1 by n, it will be 1 by n, it will be 1 by n, so your n will be cancelled out. Okay, and if I use sample, it will be n minus 1, it will be n minus 1 and n, so these n minus 1 will be cancelled out. So finally your formula will come out to be like this: summation xi minus x bar square into square root of summation yi minus y bar square, right?
Yes, sir.
Yes, sir.
And
let's end there, sir. Please, sir. We're tired.
So
Sir,
here
this is the sum covariance divided by standard deviation, right?
Yeah.
Standard deviation of x standard deviation of y. Achha.
Yes,
If I'm taking population, then again same like covariance of xy divided by population standard deviation.
Yeah. Just remember the things. If you use population standard deviation, then you have to use the formula of population covariance. That means 1 by n. If you use the sample standard deviation, then you have to calculate the you have to use the formula of sample covariance.
Thank you, sir.
Yeah, and see, by scatter plot you can easily interpret the R. Suppose there is one variable x, there is one variable y, and on the data you're like this. Okay, and you can plot the you can draw a straight line. You can say, yeah, your x is increasing, then your y is also increasing. That means there is a positive relationship. Okay, and suppose your data is like this: your x is this and y is this, and your data is plotted like this. Okay, that means your x is increasing but y is decreasing. That is, there is negative relationship. And suppose you are saying like that your data is like this, okay, circle type of things, so you can say there is no relationship. Okay, and suppose your data is like this, your x is this and y is this, and your data is like this. That means there is negative relationship. And suppose you are saying like that your data is like this, okay, circle type of things, so you can say there is no relationship. Okay, and suppose your data is like this, your x is this and y is this, and your data is like this. So you can say there is no relationship. right?
Yes, sir. What's your...
Yes, sir. Yes, sir. I think he is not audible to me. Hello.
Yes, sir. It is good.
Okay, okay. Yeah, I think till this point it's clear, right?
Yes, sir. Yes, sir.
Yes, sir.
Okay, fine. So,
Sir, one thing in correlation, there is no constant adding or multiplying that thing. It's not affected.
no, you can add actually, but see it. You can if you add.
Now
See,
we no
suppose
need to learn, right? Is it required to learn for the qualifier now?
no. There is no need to learn, but I'm explaining. See, if she has doubt, so it can be clear. See, suppose I'm adding the constant. Okay, so covariance will not be affected. Variance will not be affected. This will not be affected. Okay.
Yeah.
Finally, your R will not be affected. Okay. And suppose I'm multiplied by the constant. Okay, for each one. So I think constant will be cancelled out, right? Right? Yeah,
But
constant will be cancelled out.
Yes, sir. Yes, sir.
So again, it will not affect. Okay.
Okay.
Yeah. So next.
Yeah, I have a doubt about the range. Like the correlation is between -1 and 1, right?
Yeah. Correlation.
Yeah. So if the R comes to be suppose 0.6, so will we take it as a strong relationship or?
No,
I mean,
moderate and positive.
So 0.5 will be also moderate and 0.6 will
please
also
give me
be
the range?
moderate.
See. You can write it. I'm writing.
But here, what happened for me in GA4, I got 0.498.
See, in case it will be strong and positive. Okay. And suppose your lies between this 0.75 up to, it will be moderate and positive.
Is it equal to, is there in the left hand side? It's not mentioned.
No, it will not be equal to, it will be less than, equal to will be here.
Left side not equals to, no?
It will be equal to.
0.5 is equal to.
Okay. And
But
suppose
in the GA solution, it's not mentioned equals to left hand side. Only less
it will
than.
be weak and positive.
I will check once.
Yeah, you can check. And between -0.25 up to 0.5, it will be, you can say, absence of linear relationship. Okay.
Okay, sir.
Okay. And -0.5 to -0.25, you can say weak and negative relationship. Okay. And -0.75 to -0.5, it will be moderate and negative. Right? And -1 to -0.75, it will be strong negative. Okay.
Okay, sir. Thank you.
Yeah. You can take a screenshot or you can write it as well.
Yes, sir.
Okay.
Done, sir. Screenshot.
Yeah. Let's move at
Actually, I got 0.498 in the graded assignment R. Then what it will be? 0.498.
Weak and positive.
But my answer got 0 mark. I kept weak and positive only. In GA4, I wrote in the forum also.
Okay.
Yeah, did the calculation match the value?
Yeah, I think it can discuss it later. Right?
Mine is 0.498, so I kept weak, but the system strong, medium, and gave me 0 mark.
Okay. So I think we can check the calculation. Okay. No worry about that.
Now, actually,
okay.
If it comes in the qualifier, if I got like that 0.498,
no, if you see, just go with this. Okay. I think in the GA solution of the GA4, these things are mentioned, right?
If it is 0.5, can I take it as moderate?
Moderate. Yeah, moderate positive.
But if I got 0.498, 0.499,
okay.
Can I make it as a round figure and declare as a moderate?
You got 0.498, right? It has to be rounded to 2 decimals. So that actually makes it 0.5. Maybe that's why it's Moderate and
I think
positive.
system can.
But that answer is different. This answer is different. Now 0.5 I rounded it off.
See. Can we
But that's
discuss
what
it later? Actually,
Yes, sir.
Sure.
I think it's too late actually.
Yes,
And
sir.
see,
Please continue.
yeah. See,
Thank
point
you,
by
sir. Have a good night, sir. Bye.
1 second. One topic is left. Actually, point biserial is something association between a categorical variable and a numerical variable. Okay. See, your R is for association between two numerical variable, and contingency table is for association between two categorical variable, and point biserial is used for categorical and numerical. Okay, and formula is this one. Y bar naught is y bar naught minus y bar 1 divided by population standard deviation into square root of p naught into p1. Suppose you have category category of female, male, and male. Okay, and there is some age of their, suppose 23 or some numerical data. Okay, 52 like this. Okay, suppose I'm taking 29, 41, 30, yeah, 30 and 52. So what will be p naught? P naught will be your n naught divided by n. So I'm coding suppose female as 1 and male as 0. Okay, so your y bar naught will be average of this observations. Okay, I mean this one. Okay, by 3, and your y bar 1 will be average of these two. Okay, and your p naught is n naught divided by n1, means n naught means count the number of that means male, that is 3 out of 5, right? And your p1 will be 2 divided by 5. Okay, so you can take the square root of multiplication of these two, you can calculate the difference of these two, and you can calculate the population standard deviation of the numerical data, this whole data. Okay, that is the sigma x.
Here we only take the population
population
deviation,
standard
right?
deviation,
Not sample one.
If you want to take the sample one, then formula will be changed, right?
We have to take that sample correction factor then, if we take sample standard deviation.
Okay, yeah, it was mentioned in some class, I think. Right.
Yeah. Okay, so you have to use the population standard deviation. Okay, so it will be sigma x into square root of p naught into p1. Okay, this is the formula for point biserial, right? So I think all the doubts are clear, and the remaining doubts we can take as in.
Sir, if we take y1, I mean, this can differ na negative or positive sign. If I take 0,
you can suppose you can take it type.
Yes. So I mean, it doesn't matter if this comes negative or positive value.
No, actually, if you take the absolute value, we are generally take the absolute value for not considering the minus. Suppose in this case, suppose by mistake I code the male as 1. Okay.
Yes, sir.
So it's obvious that y bar 1 will be greater.
Yeah, exactly.
So here you can use y bar 1 minus y bar naught.
So is this a mod of this difference?
No, suppose I'm not writing it as. Okay, let it be. Suppose I'm giving the mod 1. Okay, suppose it's come out to be in minus, so automatically mod will convert it into positive.
Oh, okay, I didn't know that we have a mod in the formula.
No, in the lecture ma'am has not, I think, to give.
मैम ने बोला था कि
you have to consider, like, see, suppose your y bar naught is greater. Okay, so you can write is y bar minus y bar naught, y bar naught minus y bar 1. If your y bar 1 is greater, then like this. Or simple things, you can code the 0, which is more in numbers.
Okay, so
this formula will automatically applied.
So we cannot take this as a negative value, right? This will always be positive then.
You can take. That's why you can take the absolute of this one.
Okay, sir. Thank you.
I think remaining things we can discuss in the next session.
So it is not used for sample.
Yeah, you can use for sample. Suppose this will be changed. What is it? What will be changed? Suppose let me erase this. No, let me clear. See, your formula is for this one, right? You know the relationship between population and sample, this one, right? So sigma x square can be written as n minus 1 divided by n sx square. So your sigma x will be square root of n minus 1 into n into sx. So this sigma x will be replaced by this quantity. Right?
Yes, sir.
Fine?
Yeah.
Okay,
sir,
so
sir, that like covariance I understood, but correlation, the purpose, could you please tell me what exactly the
actually
purpose is?
covariance is gives things in in units. Okay. Suppose here is the formula of, yeah, suppose covariance is your x is in x is your suppose x is your data of height, so it will be in centimeter, and y is weight, so it will be kilogram. Okay, but correlation is used for unitless measurement. That means only know about the strength, how much strength are for x and y. Okay, so you divide the covariance into square root of sx into sy, so it will be centimeter into kilogram divided by centimeter square root of kilogram square, so it will be cancelled out. That will be the unitless measure, right? So for unitless measure, to just know the strength, that's why r is lies between -1 to 1. Yeah, one is r is closer to 1, then there is a strong relationship. R is closer to -1, then it's a strong negative relationship. That's why we use this one. Okay, I think we can close
Thank
this.
you very much, sir.
Yeah,
Thank you very much.
you for
Thanks a lot.
everyone.
Sir, how many total number of questions should we
Thank you,
expect?
sir.
You can expect around 15 to 16.
Okay, sir. Thank you.
Thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Good night.
Good night,
Good
everyone.
Thank you, sir.
Thank you so much, Prasad sir. Thank you so much.
Thank you everyone.
Thank you, sir.
Thank you.
Thank you, sir. Do we expect calculation type questions in qualifier?
Yeah, you can expect,
Calculations.
but you can expect, but calculation will be easy, not complicated like practice in. Okay.
सर वो जो रिलेशनशिप वाले क्वेश्चन होते हैं उसके बारे में सर कुछ बता दीजिए।
रिलेशनशिप मीन्स
जैसे कि मतलब कि रिलेट करके रहते हैं कि 2n नेचुरल नंबर हो गए तो फिर इसका कोरिलेशन कोवेरिएंस वगैरह।
Okay, see, tell me in the next session, I will solve.
Yeah,
Okay.
sir, yes.
Okay.
Yes, sir. Sure.
Okay, sir. I have a doubt apart from them. Can I ask?
Yeah.
Just a normal doubt. After the qualifier, we will provide a recorded lecture again, or we will join the live sessions for the class.
After qualifying the exam, actually sessions you can watch on YouTube also. Either previous, suppose you want to watch the session of week 3, so you can watch on YouTube.
अरे वो नहीं कह रहे सर।
Process will be same. जो आप कह रहे हैं वही होगा। Week wise content release होंगे
जैसा सेशंस भी
और
रहेगा
डाउट क्लियर होगा।
Week wise content clear release होंगे, क्योंकि आप if you